for joining the call for the last bit of the Geospatial Data Science course. And today, as you all know, we are going to start with the practical session today. But do you have some questions based on the last discussions? Based on the last session, do you have some questions or some suggestions or something? If no, then let me just share my screen so that we can start. I am sure this document has been sent to you. So basically, this is a material that we need to cover for the practical session. I've added some new things. So based on the last class, I've added some new things as I promised during the presentation. So I've added them on. So make sure you have the recent one, which you should be given this morning. So that is the one I'll be using for the session. So basically, we'll be doing the practical now, and this outline that I'll be following. So basically, what you need to do is that I have provided all the things you need in this slide, both the instructions, the course, everything, and the results. So for instance, I just want to demonstrate something for you. Already, I asked all of you to install these packages, the Arasta, Map2, G2s, all these packages, which I believe by now you have installed it. Okay, which I believe by now you have installed it. So how do you, if in case you have not installed it, all you need to do is to copy this part, copy only up to this part. If you copy this, and then you throw that into your R window, it will work for you. Okay, but normally when you copy from there, sometimes the quotation sign will change, so you can change this one like that. Then if I run this one, it will install raster for me. But like I said the other time, this is how will I put it? This is internet dependent. If you want to store, it's internet dependent. But if you want to library, it's not internet dependent. So those are things you need to look out for. Very, very important. Okay. These are the things you need to look out for. If you look out for all those things, we should be very fine to go. Because without the internet, none of these packages can be installed because they are dependent on the internet. But after this one, if it's about the library, doing the library part of it, which is something like this bit of it, you don't need the internet anymore. Once you first do the installation, anytime you want to library, you don't need the internet anymore. It's only once, and the installation too will be done only once. You do the installation only once. So once you do the installation only once, all the other subsequent times you'll be using it. It's just a matter of calling the library, which is the loading of the package. Then you are done. So I want to believe strongly that by now you have all been able to do that already. That is, install those packages. That's what I'm trying to arrive at. So on that note, I'm going to go straight into the business for the day. And I'll be taking it one after the other. So anytime there's something that I don't understand, please feel free and just let me know. Okay, so I'm going, this is, what you're seeing over here is in our studio. Okay, so if you like, you can work with the R Studio, or if you like, you can work with the standard R. Any of this is fine. Okay, you can with the standard R, that is fine. So,
hello, sir.
Yes, sir.
Sorry for the interruption.
No
May you start get on the installation? My phone was freezing, so I didn't get on the. Okay, I just saw I installed the other software. Yeah, so
Okay.
on the other, yeah, I didn't get the other part.
Okay, that's fine. No problem.
Yeah, thank you.
No problem. So what I'm saying is that already I asked that because the tools we'll be using for this particular session will depend on some statistical packages like the raster, the map tools, the G tools, and stuff. But I'm saying that I already asked you guys to install this at the early stage before you start the workshop. But in case someone did not install us at this time, all you need to do is to copy this part like this part. Just copy from the this material that is shared with you already. Just copy this one and then try to put that in our working session. All that you need to do here is that you need to change. You see, when you copy, you see how the quotation changed. This will not work in the R. So what you need to do is just to change that to this normal quotation sign. And then you run. And once you run, this will be installed for you. And I said that to be able to install these packages, you need internet. Internet is needed. Without the internet, you cannot install the packages. So make sure that before you install, you're connected to the internet, like I already said earlier. And then the next thing that you have to do is that after installation of each of the packages, for you to use them, you have to library them. Library simply means that loading the package and making it available for use at a particular time. So for the installation, once you install, it remains there forever unless the system crash. So if I install this raster now, I don't need to install it again on my system anymore. Unless the system crash or I'm using a different system, then that's when I will install it again. But when it comes to the loading or the calling the library so that the package will be made available for you to use, every time you needed it, once you close one session, you have to reload it before you can use it again. And so that is what I'm referring to here, this very one, library. Okay, so after you install the package from here, the next thing is what? Library the package. Library the package simply means loading the package to make it available for use at a particular time. So since I've opened this now, if I library this one right now, what it means is that I can use it anytime I want. But the moment I close this session, then anytime I want to use it again, I have to call for it again. That's the whole thing I'm trying to say. That's the whole thing. So this one is what I'm saying, that this one does not depend on the internet. The library part does not depend on internet, but if you want to install it for the first time, it depends on internet. So you need to have an internet before you can install it. But I'm saying that since once you install that one, any subsequent use of that through the library, you don't need internet. You only have to call the library and it does it. It's made available for you. The same applies to all other ones that you see over there. So those who have not installed it yet, please, after the session, make sure you install, because without, especially the raster package, the SP package, the RGDA package, the leaflet, T-map, these ones, if you don't have them, it will be difficult for you to run most of the practicals here. Okay. So on that note, the next thing I said is that there are two versions of R. You have the main R console, which is something like this. And then we also have the R Studio, which is like a specialized version of the R itself. This is a mother R. Without the mother R, the R Studio, which is this one, will not work. What you see here, this is what you call the R Studio, this one. This is the R Studio. Okay, it's also an R package, but it's a specialized one that relies heavily on the main R, which is this one. So meaning before you can install the R Studio and use it, you have to first install your standard R. This standard R can work on itself without any support, but the R Studio, which is this one, can only work after you have installed the normal R, which is this one. Okay. So just to demonstrate the capabilities, in fact, the PDF that they have shared with you, I produced that from the R Studio, but that cannot be done in the standard R. I produced the PDF from the R Studio. Okay, so that's what they have shared with you today. And then the other time to what I shared with you is also produced from R Studio. R Studio allows you the opportunity to maybe develop reports save them like a PDF or like HTML files. Because for instance, this one and this is a typical example of the ATM file. Okay, this is on the PDF. It's an ATM file. Okay, so but I can ask for the same to be saved as a PDF, which I've done, which I've shared with you already. And then even this morning, another one is also shared with you. So this is actually in the ATM file. So these are things that RStudio can do that a standard one cannot do. But for the sake of today's demonstrations, I will use the standard R, and then we'll see how it goes. This is the material that I'll be using for the session. But like I said, all these codes are the ones I've produced in the RStudio, which resulted in the PDF that they share with you. Let me even download that. Geospatial. Yes. Please, can you see the current PDF that I'm scrolling through?
Yes, sir.
Yes,
Okay.
we can see.
So there's a transcription here, but that is fine. It's not a problem because you will not even be able to use my my working directory. The first stage here is just to declare working directory so that the system will recognize where your files are and where you want to save anything by default. Okay, most of the systems like Windows, by default, the system will be saving your stuff in documents. Okay, but the type of work that we do, may you start again on installing? Okay, I've done that already. So it's always good as a professional to know where you are working. That is where you'll be saving your work and where your item that you want to keep somewhere for that very work are kept. Very important. It helps in what we call proper documentation of your work. Okay. So before I start any work in R or any other statistical software, I always declare where I want my stuff to be. That is, if I want to save something, where should it go automatically? And if I have some items or document or data or maybe script to keep somewhere for that very work, all of them to be in the same directory. So setwd simply means set working directory. That simply means set what? Working directory. And set working directory simply means that I want to declare a location where I'll be saving what? My work. I want to declare location where I'll be saving my work. So I'm going to demonstrate that right now for you to see. Maybe in case some of you don't know how to set a working directory in R, I'm going to demonstrate that for you to see. This is the first stage of our work. So give me small time. Let me just showcase that. Maybe on the other side. Okay, so maybe. Let me see. Let me, just for the purpose of for you to see better, let me create a new script. And I'm going to demonstrate something for you. Please, can you see the empty script here?
Yes, sir.
Okay, good. So what we'll do is that first, let me show you something. I'm going to show you where I want to keep my files and where I want to work for this Geospatial workshop. So you see this place, all the things that are here are the things that I needed for this workshop. So I have to keep all of them at one place. So I created a folder called modeling course. I created a folder called modeling course. And all these things are in there. These are some of the special, predictions, the regional boundary of Ghana, and then some sub-national boundaries, the shape file that I will need for the special modeling or mapping and stuff, then other things that I just put for the workshop. So anytime I come to this folder called modeling course, I'm aware that all my items are here waiting for me. So anytime I need them, I don't need to struggle to go and find out where they are. I know that definitely they'll be in this folder. The same way, I want to run my analysis and save them in the same folder. So that anytime I run something and I want to check how it looks like, I can just come to the folder. That is basically the whole of this business. So for you to be able to create your working directory or set your working directory apart from the default, all you need to do is to come and copy this one. This is the link up to the modeling course where my cursor is. Do you see that one? Please, do you see?
Yes, sir.
Okay, so all I need to do is to right click on this one, right click it, right click, then copy address. Right click, then copy address. So I click on that one. Then I come back to my slide, the R script session. All I need to do is to do set working directory. Then I'll bring a close bracket and then I'll bring quotation. This is the start of the whole thing. Set WD, which is set working directory. I want to declare where I want my work to be saved and when I have my files for the same assignment. So after that, the next thing I need to do is to paste it. I've copied it, so just paste. You can see that something is pasted inside. Let me make it long so you can see the whole path. This is something is pasted inside. You see it. So that is the link to where I want to be saving my work. That is where the folder is, where my files will be saved or contained. Okay. But in R, I don't like backward slash. I do not entertain backward slash. So you have to change the backward slash to forward slash. So all I need to do here is to change the backward slash to forward slash, all of them. This is the surest way to be sure that you copy the directory appropriately. Because if you want to be looking at it over there and coming here to type it one by one, you're not finished now. So this is the surest way of what? Copying and then creating the directory. So now my job is done. All I need to do now is to press, there are two ways of running or executing add command. You can put a cursor inside the script, put your hand on the control, and then put your hand on the R. While your hand is resting on the control, you press R. Then that will be executed for you. So this is done for me. So you can see this is done. It means I've declared my working directory.
So,
Meaning,
sorry, please.
yes.
Sorry, please, sir. Can you come back again with that?
Which one? Come again. Sorry.
Yeah, to execute the directory.
Yeah, you can just put your cursor inside the script, the command you have written, put the cursor inside it. Then let your hand be on the press, hold down. You know, you have a control key on your laptop, control key. Can you see the control key on your laptop?
Yes, sir.
CTRL. So you press your hand on it. Let your hand be on it. While your hand is on it, then press R. Letter R.
Okay.
Press letter R. While your hand is resting on the control key, press letter R. Then it will execute it for you. Or you can just select the whole of that line. This you highlight the whole of that line. Do you see it? This is what I highlighted.
Yes, sir.
Yes,
Or you
sir.
can highlight the whole of that line, then you come to this one. Look at the top left.
Okay.
There's an icon there called run line or selection. Do you see it?
Yes, sir.
So if I click on that one too, that will also do the same way for me. But it's easier using the control and then
Control R.
It's easier with that one. Instead of you highlighting the whole of this and going to click on this, you save time. So that I say that this one also work. They're all going to work, but the control R saves a lot of time. So please, this is my working directory. It's not for you. So if you run this on your system, it will not work because my working directory is not the same as your own. Do you understand? Please, do you understand?
Yes.
So the process I went through, you also have to go through that process to go and copy your directory where you want to be saving your work. After that, you come back to R and then declare that directory through this process. So that's the first bit of it. I have done this now. So once I've done this now, I can even go back and start loading my stuff because that is where I need it. So I have already installed the packages, so I can just library them. Again, I use the control and the R function. So I just go. I just run all of them. And then when they are done, I'll know. Now it's already done now. So I've libraries, like I said earlier, simply means that I am asking for all these packages to be made available for me to use because I need them now. And if I close this session and I come again, I have to library them again because once you close the session, they are gone. They are not permanent. But all you need to do when you come back, you have to run them again. The only thing you not need to do again is the installation. Once you install once, that's it. You don't need to install them again. Once you install once, that is it. You don't need to install them again. Okay. Now I put some links here. These are some of the links to where you can grab some surveys that are specially indexed for your practices. For example, if you want some data on Ghana, you can use this link, and this link will take you to the website where you can grab that data. So let me just demonstrate this for you. And this data is indexed as special information. So I go to the internet. Let me see some messaging. The link, actually the link is already in your the document I sent you, the link is there, so don't worry. The links are already in the document I sent you, so if you can look at that document, but that's fine. See, instead of using brackets in Maria, you're supposed to use the bracket, the second one. You're using a square bracket. It's not the square bracket, it's the second one.
Okay, okay, thank you.
So I'm just going to paste the link into the browser to see how it looks like over there. So here, this is basically for Ghana, as you can see. One, because I use the link of Ghana, so you see Ghana here. This is for 2019 malaria indicator survey, 2017 maternal health surveys. A lot of surveys are there that are specially indexed. So you might be doing some work that you need to showcase this. But naturally, how these things will come, they come in a very raw form. So you have to grab it and then do another mapping that will make you look better for your presentation and other stuff. Okay, so these are very, very important surveys that you can think about. So here you have the DHS boundaries and other stuff that you can download for use. You also have the DHS data survey details here. If you want to read more, you can see them here. Everything is here actually. So I'm just going to take the other link also. I'm just trying to expose you to the various links that you might need. There's one at the top here. The top one here is general one. So this one is for everything. So when you use this one, you have to not select the individual countries. But I put this one out for Ghana so that at the end of the day is equal to GH, meaning for Ghana. And there's another one. This one is general one, the single service, this one. So this is a general one. Okay. So you have okay, so it works now, right, Maria?
Yes, it worked. Thank you so much.
That's fine. So you want a general one, which is this one. Here, all the countries are here. Here, all the countries are here. Data from DHS indicators and US Census Bureau population estimate and projections can be downloaded in GIS format. So all of them are here. But again, these things depend on the internet. So you need to have a very good connection to be able to access this data. So here, this is where you want to use single countries for your work. For instance, if I want to use Ghana, I have to click on this side. But if I want to use multiple countries, I have to click on this side. But if I want all countries for most of the indicators, then I have to use this one. So this is like the world. This place is like the world. This place like if you want to download several countries together. But if you want the world geospatial map, and then the shapefile, this is the one. But if you want individual countries, this is the one. Okay. So assuming I want the individual countries, I just click on this one. So now I have to select the country that I want. Let's say I want Ghana. So I'll just select Ghana from here. So any country you select, it will display for you which data they have available. Any country you select, they will display which data they have available. So this is telling for Ghana, they have data for 2019 malaria indicator survey. They have 2017 maternal health survey. Here they say no data, South National about this only, no data. 2016, the same. Then 2014 DHS, they say they have the model surfaces. They have the model surfaces. This is some of the things that we do a lot, the model surfaces. So maybe let's select 2014 DHS. And there might be, let's assume that's the only data we want from here for now. Then you say continue. Like I said, it depends on the internet. So when you are doing all this, remember you need the internet. And here it's showing you all the indicators available. It's showing you all the indicators available. Indicator simply means the outcome of interest or the variables you want. You have information on fertility rates. I do a lot of work around children and women. So maybe let's see under 5 children, something like under 5 mortality is also here, something like this. So here, all you need to do is to say edit. Edit, once you click on edit, they will show you all the indicators available. Then those you want, you select, and those you don't want, you deselect them, okay? So first, what I want to do is to clear all of them. And then now I'm going to select only those that I want. Let's say I want to do something about under 5 mortality rate. So I'll click on this one. So here you see the thing coming, early childhood mortality rate, children, under 5 mortality. Do you see that coming up? Or if you want to do some work on stunting among children, you can click on this one also. So here, meaning we have 2 data sets that we're asking for now, under 5 mortality and then malnutrition through stunting among children. That's it. So if these are the only things I want, I can just click on continue. Now look at this one. It's asking me, how do I want it? Is it at the national level or sub-national level? In Ghana, national level mean the whole of Ghana. Sub-national could mean the districts or maybe regions. So if you click on sub-national before, you will see what they'll be giving to you. So let's see sub-national. And then it's asking you which format do you want to download the special data? Is it shapefile or database? They are all special formats anyway. But most of the time we use a shapefile, but others also use the database as well. So now after that, they ask you, how do you want to download your data? Do you want them to send it to your email or you want to download it directly in the browser? Okay. So for now, let's pick the national one, and then as you want to download in the browser now, at least so that you can see how the situation works. But if you choose your email, they will send it the data straight to your email for you. Here I'm using the browser, so let's say I go. So I'll click on download. Like I say, it's internet dependent, so the system is now preparing these 2 data sets from 2014 DHS, that is the under 5 mortality and then children's stunting. But okay, that's just a procedure. It's taking a bit of time, but that's a procedure. You see that this is going around here, indicating that it's preparing the data for you for download. So when you go at your own time, because we will not have that time to wait in all this long. When you go, you can practice it yourself. It should work for you easily, no problem at all. Okay. On that note, I'm coming back to the business for the day. So I have shown you how to set your working directory. And you can download the DHS 2014, which I'm doing right now, but the system is delaying it. But you don't need it. I've sent all these things to you in your, they sent you some zip folder or file last time. All these things that we needed today are there. I'm just trying to showcase to you how we downloaded them. I've sent all those things to you already. So all you need to do is to unzip the zip file that was sent to you in your working directory and keep it just as it is. When you unzip, just copy as I've sent to you like that and then put it in your working directory. As I've done here in my case. As I've done here, this one. As I've done here in my case. So when they give it to you and then you unzip it and you copy all of them and throw in your working directory, which is a folder in which you are going to work, everything should look like this. These things should all be there. So these are the share files and then those things I wanted to download now and stuff. They're all there, so you don't need to struggle. Now on that note, we have to start loading some of the data. First, what I want to showcase how to do with you is to map under 5 child stunting in Ghana, which I'm trying to download here. The one I'm trying to download that is not, which is not done yet, it's still loading. This one, children are stunted, this one. This is what I want to map for Ghana. So, like I said, this already in your, the zip folder that I sent you. Once you zip, you should get it. But I will demonstrate all those things for you again. Yes, please, you have all the add commands. You have, somebody's asking if they have all these commands. Yes, you have all those commands, okay? You have all those commands. So you go to the PDF. Let me open a PDF. If you go to the PDF that I sent to you, you go down. Already I've told you about library, doing the library for those things. So you see this one, this is where we are now, here, mapping under 5 child stunting in Ghana. This is where we are now. It's on the PDF, that's the special data science PDF that I've sent to you, is there. So this is where we are now. And the links I just discussed with you, they are just, everything is down there. You are here, you can see it, it's in your, so you have everything, There's nothing left, you have everything. And then this is where I try to demonstrate for you how to do setting of working directory, and I've demonstrated that for you already. And I told you this one is truncated because it's too long, but I've just demonstrated that for you. So you have everything that I'm doing. So right now, what I've just said before, somebody asking, do you have all these things? This is what I was saying. We are going to map lattice data, and that is mapping under 5 child stunting in Ghana. Okay. So I'm going back to the R script. So this is what you have just seen, mapping lattice data, mapping under 5 child stunting in Ghana. So all you need to do, you have to be copying it from that. If you want to follow along with me, all you need to do is to be copying from there. Anything I do here, once you understand, you copy from there and also practice on your own. But I want you to first look here and understand what I'm doing before you can go and practice. Very, very important, because if I'm doing this and you're moving in between, you are likely to lose focus. But if I explain all this to you and I run it and they realize that it worked, then it's easy for you to copy from there and then do, because the course, everything is on the PDF over there. So right now, I need a data for stunting variable. It is captured in the folder called this. And that is also the same name given to the stunting data. So let me show you. Let me go back to my working directory and you see how it is. This is my working directory, okay? And then these two are representing 2 different outcomes. So you need to know which of them is representing what, okay? And all of them are here. These are, some of them are about vaccination and others are about stunting, okay? And this is where we have issue around the stunting and stuff. So what you need to do is to be sure which of them you are calling. If you look at this one, we are calling for the one that ends with MSCI. MSCI, or you see the HA2 here is actually used to index height for AZ score. Height for AZ score is supposed to be HAZ, but this is how they differentiate it. HA2. Okay, that is for height for AZ. That's what they normally use to measure what stunting. So if a child's Z score is below -2 standard deviations, then they will classify you as stunted. Else you're not stunted. So you can even look at that in the folder to differentiate that this is for stunting, which is high for AZ score. Okay. So if I come back to my folder, it is this one. You could see clearly this one here, the HA2. So this is one I need. But what it means is that the file is not directly in the working directory, but is rather inside another folder. So the working directory itself is a folder. Then there's another folder inside. So I'll need to open it before I get what I want. Okay. This is what I want. This is what I want. Okay. But this is also located in another folder. So what it means is that though I've declared my working directory where I want to save my thing, before I can run this work, I have to introduce another folder in the command before reaching what? The very item that I needed. Okay, that is a procedure. And if you want to know more about this is the file, this PDF explain everything here about what this is representing, what each of them, some of them are standard deviations or standard errors that measure uncertainty and stuff. Okay, so this is what I want to map. So what do? You see something here. This is the first part, which is a folder. This is a folder in which that item is stored. This is a folder. So I brought / again. Then this is the name of the file containing the stunting variable. This is the name of the file containing what? The stunting variable. And this file is saved as .tif, which is like a raster file, .tif file. Just as you have a .doc, .tif, .png, .jpeg, and all those things. This also have an extension. So the extension for this file is .tif. So it's like a raster file. Okay. So if you want to be sure, you can go back and check. If you put a cursor on it, this is telling that this .png. We put a cursor on this. You see this thing, this or .pif. They're all telling you what extension each of them is having. So this one like this is TIF. But the first one here, this is telling you this is what? PNG file. The second one is telling you that this is TIFF file. The next one is telling you that this is what? PNG again. This again what? TIFF file. But we are reading in using the TIFF files, not the PNG files, because that's what the raster will easily understand. So we are reading in the TIFF file, so which is this one. And the standard error is this one. So we're reading the TIFF files. The PNG files are the one you're seeing the images directly. But TIFF files will not display the images directly until you read them. So it is this first one we want to read, which is a stunting variable. Okay. And after that, if you want a certainty, which is the mean underscore that, you can read that also. But now you want to map the prevalence of stunting among children under 5 years in Ghana, which is this very one, based on the TIFF file. Okay. So this is what the program produced. This is what they have. But this is not looking good. So we want to improve upon this for our presentation. Okay, so this is a typical type of what we call lattice data. This is not looking good. This PNG file is not looking good. So we want to find a way to harmonize or to improve upon this map. So that is our work now. Okay, so this can go. So I'm back here. So we want to now use this one so that we can use our hand and run it and see what we can do. So that brings us back to the R script here. So this first one, if you want to read in a raster file, I think there's some message. Please, the MS-V01 is just the name given to the file. It can be any name at all. So it's not like any command or any code that is used. It's just a way of identifying the codes. The first one that I show you, which is this one, this one like this, is just a name given to identify each of the files. Okay, so this one, like the whole of this, what is inside here is just, I can change the whole of this name to my name. It doesn't matter. It doesn't change anything. I can even change this one to ABCD. It doesn't change anything. But what matters to us is the content of the element. So this is just you giving name to represent something. So it doesn't depend on anything. I can even give this, I can change this name to like a girl or a boy. It will still work. Because what matters is the content of it. Okay. So the MS, it doesn't really mean anything. It's just the name given to a file. That's all. Okay. So after that, this is how we read in a raster file from the T format. First, give it your own name. It can be any name at all. Maybe I can just say file, or maybe 1 or 2 and 3. I can do anything. Then bring the folder in which the file is stored. Then /, then bring the name of the file itself. Then remember the extension .tif. That's what we are reading. If you don't put the extension, it will not work. If you don't put the extension, it will not work. Just as if you are reading data from a stata, and you didn't put .dta, you can't read it. You see, if you are reading data from R, and you don't put .r data, it will also not work. Okay, so these are things you need to take notice of. They're very important all the time. So all I need to do is to run this guy now. But remember that for you to run this, you need a raster package. And that is why I have to run all those packages first to make sure that I have them ready. If I were not to run, load the raster package, it will not work because this depends on raster package. So I can run this one now. This is just a naming. It doesn't depend on anything now. Where the real work is done is here. So this is the name I want to give to the file. I say stunt_mean. Stunt_mean. So that would be the prevalence of stunting. Then equal to here, follow. The what is here is the function that I need to read a raster file in the .tif format. This is a function that I need to read the raster file in .tif format. So the next one in the bracket is the name that I've created for that .tif file here, the one here. I just put this name back into the bracket. So once that is done, my people, my job is done. I can just run this now and I can start playing around it. Since I didn't get error, it means it worked. That's why I put here worked. If there's an error, it tells you that it doesn't work. So you need to change some few things. Now, once this is loaded now, I know you'll be wondering, so why is it? There are ways that you can map a special data. There are ways that you can map a special data. So just reading it here doesn't mean you are done. You can use a plot function. You can use a tmap function. You can use a leaflet function to map out special data. There are many ways of mapping it. So though I've read this correctly, I need to now be able to map the values inside this file, which is stunt_mean. So first I want to use a plot function, which everybody knows about, the default plot function. That is the one I want to use to first display how it will look like for me. Just to display how it will look like for me. That's what I'm doing now. So I'll run this one. That's just the normal plot function that you know, plot something. This is what I'm doing. So I run this one. So this is what's happening on the right side here. Please, can you see what is on the right side? The map.
Yes, yes, sir. Yes, sir.
Yes.
Is it very clear to you?
It is.
So this is the basic way of plotting special map. when you have a raster file. This is a basic way of plotting it when you have a raster file. Okay, very, very basic. But if you want to use this map for maybe publication or presentation and stuff, this is not acceptable because, if there's a lot of space on the left and the right side of it, this could have been expanded and that kind of stuff. We need to do some few things around it. But at least it's giving you an impression about the stunting prevalence across Ghana. Okay. The more the green, the higher the prevalence rate. Do you see that happening? Because you realize that the whiter you get, the lower the prevalence, and the greener you get, the higher the prevalence over, let's say, from 10% going. But the white parts are just about 2% thereabout. Okay. But this is not an issue. This is not an issue. The problem is that stunting is not a good thing, it's a bad thing. So in our work too, we think about color. In our work, we think about color. Unless someone would say, okay, the white symbolize something which is good, but how about green? Green also symbolizes something that is good. Is that not it? If they say you have my green light, you have the green light to do ABCD, you're giving go ahead. That means everything is fine. So in our way too, we think about color also. So it's better to identify colors that truly represent the situation, so that those who have the low prevalence is better. And then you give them some good color that people can, easily recognize to be a good color for good things. The area that are having the high prevalence, relatively, you give them like colors that symbolize bad things, like red, or maybe something else, or black. Okay, so in our work too, in mapping work, we think about colors as well. We don't just get up and use colors. You have to look at what you are mapping and see which color will go for the good one and which one will go for the bad one. So like, for instance, in this case, I might decide, okay, I want green to go to the good part where the prevalence is low for stunting, and red to go to where the prevalence is high for stunting. So that whoever is reading the work knows that, oh, these colors are speaking even in the direction where the things are looking. Okay, so this is just by the way anyway. But these are some of the professional things that you have to be doing along the line. Now, I just load the data and I plotted for you using the default plot. You might want to know what the class of this data is. Even though already I say it's a raster file, it's good to also confirm if indeed it's a raster file. How do you do that? Just type class. Just type class and then bring in the name of the variable. So this will tell you what kind of class or what type of data is this one. Either it is a special polygon, special point data frame, either it's a raster file, or whatever it is to display for you. Or either it's a data frame, anything, it will tell you. Okay. So I'm going to run this one just for us to see what kind of data is this one. So on the left side here, you see, it's telling you this what? Raster hot layer. And which package produced that? It's say from raster package, that's raster. So this is a raster layer and from the raster package, produced from the raster package. Okay, so that's it. In fact, you may also want to have a summary look at what is in there. You might want to look at the values in there. So you can just run a simple summary, which is this one. If you run summary, then you bring the name of the file you have loaded. It will tell you the minimum, the median, the mean, the maximum, and some few additional stuff. So let's see. So you have the minimum to be this value. Remember, this is times 10 to the power -2, so you know what it means. That would be like 0.198 thereabout, 0.0 something like that. They have the first quarter, the median, the third quarter, the maximum, and you have some missing data. We call them NAs. You have some missing data. So this one definitely they will lie outside the country. Maybe they are outside the country. That's where the system will set them to missing. They are not within. If they are to be within the country, Ghana, you will see that it will be included as part of the key, the NA that you show the color, but we don't have NA in this parts. So they automatically be removed from the mapping. So that is it. Now we want to use another function that we call tmap. Please, like I said earlier, all that we are saying here is on the slide I've sent to you already. These ones. So this is where we do the plotting using the default plot. So this is where we did a checking of the class. This is where we did a summary. And now we are going to use a tmap to do it. Okay, so everything is here. But like I said, be with me, understand what I'm doing, so that when you go, you can do your own stuff. What do we do to name this? How do we read a folder of stunting? Oh, no problem at all. If you want to change that name, it's up to you, my people. It's up to you, because this one like this, here, I can even change this to stunting straightforward. This one, I can just change this to stunting. Okay, let me not change this one now. I'll clean it anyway, but let me just showcase this one. So there's nothing wrong at all. I can change this one to be my name or even the stunting itself. I run this one stunting. Then I can repeat the same stunting again. Oops, raster, stunting, raster. By watching the name, quick one. Is the same raster. I've changed the name, yeah. Stunting. So I'm going to do the default plotting. Plot, come on. Stunting. Run. Just for you to be sure that it is correct. So I'm going to clean the first one. So just run. The one who asked the question, do you see what is happening? It doesn't matter. Changing the name doesn't matter. Just make sure if you change the name from here, when you get here, you maintain the same name inside.
Yes, thank you. So the problem I'm having is how can I specify the that folder? I see that you assign that folder to stunting, and then in my computer, how can I specify that specific folder when I want to assign that stunting option?
Have you declared your working directory already?
Yes, yes.
So, for instance, you are, where are you? Okay. For instance, you have something like this in your working directory, is that correct?
Yes, yes.
So what you need to do first, to make sure you didn't do anything wrong, first copy this one like this, do this one. Then you copy it, okay?
Yes.
Then when you come to the R scripts, that you paste that one for the first part here.
Okay.
Can you do that now?
Yes, I can do it.
Okay, please do. Are you done?
Yes, yes, I'm done.
Okay, then bring / this one.
I'm done.
Okay, so let's go back to the file again. Now, open this one now. Open that very one. Then you come to this one. Again, do like you want to rename it. Are you there?
Yes, yes, I'm there.
Okay, then right-click and then copy that one. That one. Done?
No, not yet. Just
right-click that and then just copy. First,
okay.
Put a cursor on it. Right-click to say you want to rename.
And then copy. Okay.
Then come back and right-click again and then copy.
Okay.
Done.
Yes, yes.
Come back to your R script. After the slash, drop that one here.
Is it the TIF file?
Come again. Yeah, the TIF file, yes.
Yeah,
The
okay.
TIF file, yes.
Okay.
Are you done?
I'm trying to copy the name of the file.
Okay.
Copy. Yes, yes, now it's okay.
Did you paste it here now?
Yes, I already pasted.
Okay, so do you have the .tif at the end?
Yes, I have it.
Good. Make sure you have this, the apostrophe, this one. Do you have it?
The apostrophe.
The one here, the one I highlighted at the end.
Yes, yes, I have it.
How about the start? Do you have it at the start also?
Yes, I have it also.
Okay. What name did you give to it?
It was the first name, string
That
name.
is fine. No, keep it. That is okay. So can you run this now and tell me what you get?
Yes, let me run. Yes, now it works.
Okay, now come to the next line. That one will give it a name. Let's use what is just so that it will be the same across. So give it the name stunt underscore mean, this one.
Yeah, stunt underscore mean equals to raster.
Yeah, then to bracket the file name, they'll bring this
Yeah.
one.
Yes, yes.
Did you do that?
Yes, yes.
Now run it, let me see.
So it says that there is an error in Rust objects.
Okay, go ahead.
Can you allow him to share his
Yeah, sure,
Yes.
sure. Let me see if I can
Yeah,
let me see multiple sharing.
yeah,
Okay, try sharing and see what they will tell you. Try to share your screen and let's see what they will tell you.
Yes, but I don't have any option of share. I don't know why.
Okay, let me
I
see.
think he has to set.
I've allowed it, so please share.
Okay, they say you're allowed to do so. Please share your screen.
I think now you can see my screen.
No, I cannot see yet. Maybe it's loading. Or maybe I have to stop my own first.
Maybe. I don't know if others they can see my screen.
I can see your screen now. Yeah.
But
Okay. So you have object that / you have that. Then store underscore me equal to raster that, which is fine. And then so let me look at the error down here. Store equal to the error in so object from so band layer cannot create a villager from this file. File does not exist. The file does not exist simply means that you did not have that in your working directory. Can you go back to and share your working directory with me? Please open your working directory for me.
yeah, the working directory is this one.
You open it for me.
Yeah, I make this as
It's data. So what you need to do from here, you copy data. So let's go back to the script.
Copy to the scripts here.
Yeah, the R script. Yeah. So show me where you declare your working directory. Go up.
Yes, here.
I didn't declare working directory. I can't see it.
Here at this stage, I think you can see this line.
Yeah, but I want to see it from the code. This is not correct. That is not correct.
Oh.
Yeah, if what you show us was data and you are seeing output at the end here, so that is incorrect. It's not possible.
Okay.
You copied this wrongly from somewhere. So go back to, can you allow me control?
Yes, yes, sir. Let me allow you.
Allow me control so that I can have access to your system.
Now it's good. I will allow you.
Very well. So we go back to your working directory. All right. So you copy from here, copy the address, yeah? You go to the scripts. So let me do this. You can even do that beforehand. So working directory. That. Go back. Once. Let me see. No, you. Where can I locate it? I'm trying to get back to the working
directory.
Yeah, yeah.
Here. Here.
Yeah, here. So someone is saying I have to copy this one set. My own, I can just copy as a DC, but others, someone is saying I have to copy like a text as address.
Okay.
So let me go back to the script. Can you go back to the script?
Yes, I can go back.
Okay. So I started typing somewhere here.
Yeah.
Okay. So I have to change the backward slash to forward.
Yeah.
Oops. So we start from here so that I get it right and forward. Forward.
So the problem is that
You did not
I
declare
say-
working directory. You didn't declare
okay.
working directory
Didn't.
correctly. What you have over there is not what you expect. That is not why you save your stuff. So this is why you save your stuff.
TR sections.
So you have to run this one. You run that. So now let's go. So this already there. So all you need is I can run this again just in case. Come on. So you run this one. You can now run this one, and that should work.
Yeah, it works now.
You can now plot. So that's why I said that make sure you declare working directory correct. If you don't do it correctly, you struggle. Okay,
Yeah.
you can take back your control and then
Okay. Thank you.
take over these things. But you can save that file now.
Okay, thank you very much.
Okay, you can take back control and then those. Okay. All right. So let's go ahead. I think it's that one. Yeah. Well, let me just share the screen entirely. Okay. So that is that bit of it. So the next thing is just to use some other techniques of doing the same plots, but that might make it look much better. That's the whole strategy. So the next one function that you can also think about is T-map. It's normally used to develop thematic map, but it's also good for things like this. So first, the same as you can see, the command start with the. So this is coming from a package called T-map package. The T-map package what we use for this one. And the command start by you writing the TM_shape. Then you bring the name of the data that you have. And then when we did summary, look at how it is. When we did summary of the shape file, the name of the variable itself will always be here, this one. Okay. So this is stored in this. So if you want to use a T-map, it will not behave like the plot function where the moment you say plot, it will remember that you're talking about this. No. For T-map, it's asking you to give specific name in the data set that you want to plot. So after bringing the name of the data, which is stunt_mean, you also have to specify what exactly you want to plot within that data set, which will be this one. So treat this like the data set and treat this like the object or attribute within the data set. So you have the data set name here. And then the attribute that you want to plot is this one. The attribute that you want to plot is actually, I'm taking my time because these early stages, but once I'm able to do 2 or more of these, the rest I will flow. So please, I want you to pay attention. So once I grab the attribute, which is this one, put it here, all I need to do is asking me which column of the data I want to plot, which is attribute, which is this one. So once this is done, this will also give you a default map based on T-map, just as the plot function gave you. This also gives you a default map based on the T-map. Okay, but it will look different from this one that you are seeing here. So let's see. Again, you just run. So do you see what is happening right now? Where you are seeing the white, these are rivers. Where you are seeing the white, these are rivers, okay? Right. Now, for you to see the difference between this and the first one, you can do S11 bracket to create a new window. So I'm going back to run the first one based on plot function only. And we can now compare the two in terms of the look. You see that they are presented in a different way. If you look at a T-map is even giving the name of the attribute at the top, then putting the ranges from 0.00 to 0.02, 0.02 to 0.04, up to the highest, which is 0.12 to 0.14. But if you look at the natural plot function, it's doing this on a continuous basis. But this one is doing it based on what categories, from this to that, from this to that. So you can begin to see how each of them present themselves. And in fact, if you look at the first one, it really gives you the axis for X, and then the Y, which is the longitude and the latitude axis. It gives you those information also. But if you come to this one, it doesn't display that. But there's a way you can ask for the what you call the kilometers per second, so you can ask for those things at your own time. But these are just the raw or the default plot functions. We can make this better by moving even the scales to this side and making the scales even much smaller, and also changing the colors of the map. We can do a lot of things around this. So that's the next activity for us. So I will keep this one here, and I will be playing with this one here based on this one. So let's go back to the script. So now at this stage, instead of allowing the system, I'm doing many things here at the same time, but don't worry, it's not too different from the first one. The first one we did for T-map, we block this here, which is the name of the data set, and we block this here, which is the name of the attribute data set. Is that not it? This is what we did earlier. Is that not it? Now, we added this component now, title. This is going to give the map a title. You have to say maybe proportion of stunted children or proportion stunted. Okay. So that if you see the figures, you know that these are actually proportion of children who are stunted. But the earlier one didn't give us any information about what exactly we are presenting. So if you see the two maps, they don't tell us what we are presenting. All you see is figures and the map, that's all. All you see is figures and the map, but it really didn't tell us what we are mapping. So it is the title now that will tell us what we are mapping, or tell whoever is going to look at it what we have mapped. That is proportion of stunted children or proportion stunted. Here, I'm trying to introduce a star called fixed. Fixed here means that I want to fix the scales, these ones, the values that they have displayed. I want to fix it myself. I don't understand to decide on it. I want to fix it myself. Then how do I want to fix it? I say, okay, from 0 to 0.05, then to 0.07, to 0.08, to 0.1, and to 0.13. Because in fact, if you look at the original distribution, it ranges from, the maximum is around 12.6 something. So it's not even up to 13%. It's about 12.6%. But we are doing it from, okay, this is almost 0. So from 0 up to 13. So from 0 to 13, which interval do I want them? So from 0 go to 0.05, 0.07, 0.08, 0.1, then go to 0.13. So you realize that everything here will lie between this interval. This is asking me, do I want to put the legend for as a histogram against the legend? I say no. I'll run the first one, and then I'll run the second one to display what this. If I say true, apart from these values, it also display a histogram of how the values looks like. If I set this to true, it will display for me these values at the right side, and at the same time too, it will show histogram against them. So I'm going to do the first one with that one, then the second one with that one. Then you see. This is asking me, where do I want to put the legend? Where do I want to put the legend? I want to put the legend outside the map. You see that this one is inside the map. Do you see? Current one, they put it inside the map. Do you see that? But we would like to put it outside the map, like outside this, something like this place, so that to not cover the map itself. So that is what this one will do. It's asking me, do you want it to be put outside or not? I say, yes, put it outside. Here, I just want to put a scale bar to the map, scale bar to the map. I want to put a scale bar to the map. And it's asking me, where do I want to put it? I say, right bottom, right bottom. So it will go to the right and to be at the bottom. So somewhere here like this of the map. This is where I want to put it. Okay. Once that is done, all I need to do is to run this. In fact, if you like, I can highlight the whole of this first. Then again, your Control and R, that one to work. So we are here now. Now compare these two maps. Which one is beginning to look better? Compare these two maps. Which one is beginning to look better?
The second one, sir.
Yeah, the second one, the one we just produced. This one is looking much better than this one. Okay. You see that here we reduce the scales and we even give a name of the thing we are dealing with, proportion stunted. And then we even provided a scale bar, telling you how many kilometers on the ground presence and so on the map. Okay. But this one, nothing like that. Okay. But another thing is also take note of is that this time around, we are able to get better colors. You see, if it is light yellow, then the prevalence of stunting is low in those areas. But the deep red or the deeper red you go, then the higher the prevalence. So this makes sense because stunting is a bad thing. So if areas where the risk of stunting is high, we give them deeper red, that corresponds to the situation. And where the stunting is low, we give them lighter yellow, that is fine. Okay, so this is now making more sense than the first one we did by plotting the default. Okay, now we can still improve on this more. So in doing so, like I told you something about if I want the histogram to be displaced against this thing, so I can change this one to true. Don't worry, I'll revert it to true. And you see that beneath this, they'll put a histogram there telling you which proportion lies at a certain level, just like a summary. Put a summary on the map. You can also do that easily. So now do you see? So this is telling you how many people were within zero, the frequency, and up to the higher areas. How many people were actually likely to be found around the highest areas, which are running to the deep red. You see? So this time the majority of the people are not stunted, but we still have some good amount of them who are stunted, as you can see, moving to the deep red. So this is a histogram displaying the distribution of even the stunting level in your population, which is very useful for summary purpose, because if you say these areas are stunted, we want to know the proportion of stunted across the entire geographical space of Ghana. And this histogram is summarizing just that for you without any further struggle. It's summarizing that for you. So apart from knowing that these areas, children are more likely to be stunted compared to other areas like these ones, it's also giving you the frequency of that stunting prevalence for each of the classes that we have, as you can see. Okay, but yet, for now, let's keep it to false. Okay. Now, even there's a procedure that we can use you see the proportion started is too long here. So it has taken some space away from the map. We'll have had a larger map, but because proportion started is too long, it stretched the map to the left. We can separate this one also. We can separate this one, but this will be more meaningful when you're doing the web-based aspect, But let's give it a try. So here we want to, this is how we break it. Some you do less than BR, then you close it greater than, then that will give a space. But some other packages you have to do backward slash with N. That's how they separate it. So I'll do this one first and see which of them works. If this doesn't work, then I'll try the leaflet one. Definitely that should work in the leaflet app. So again, that's the only thing I've changed here. And this time around, we are running breaking the title. That is all we are doing. We are running breaking the title. So let's see if that worked correctly. So this is what is happening here. Do you see the difference now? Do you see that now, instead of having a very long proportion started, now proportion started, you have it started under the proportion. So it minimizes the space for you. It actually minimizes the space for you. So instead of having the proportion started on a straight line, we break it into two. Proportion at the top, something at the down. So that is actually taken care of by this guy. It is this guy, only this simple function that made the magic. Okay. Now, sometimes you might want to produce the web-based version of the map, the web-based version. Please, if you want to do the web-based version, this guy here will not work. This one will not work for the web-based version. The one that will work for the web-based version is this one. This is the one that will do for the web-based version. So we want to create a map first, then convert that into a web-based. And this time around, because we want to go into the web-based, we have to give it a name. You have to give a name. The first few you have done, you have not assigned a name. But for this one, you have to give a name. So here we are calling the name stunting. That will run the same thing again. The only thing we change here is this guy. Instead of the backward slash and the end, we are now using less than sign, BR, and the greater than, standing for break. This is a language that the leaflet will understand, break. So meaning that after proportion, break before you bring a stunted. That's the meaning. So go to the next line before you bring stunted. That's the meaning. So that's the only thing I've changed here. So this will remain the same, but the map will not look like what you are seeing now, because it is only when you get to the leaflet that this will reflect. So you see this at the top of this one, but don't worry, that is the procedure. So I'm going to run this now, and you see. So this is that now, instead of the stunted going down, it remains here. Do you see it? Because this is not a language that TMAP used naturally, but because you want to move this one into a leaflet, which is a web-based application, and that is where we have to keep this as it is. But this is not our final destination, so don't worry at all. If you want this to be a final destination, then you have to come and use this one, the one we produced earlier, this one. That's if this is the final map you want to use, then you have to produce one so that you have it corrected like this. But the second one we are doing, our final destination is not here. Our final destination is getting to the leaflet, which is the web-based version. So this will remain here. So that's why you see this one remaining here. So to finish the process to get to the final destination, we now have to run this again. I'm just assigning this one as a name again, stunting_web, to show that I'm going to the web version of it. Okay. And the function you need for the web version is tmap_leaflet. That's the name you need for the web version. That's a function that will work for you. Okay. Then the next thing that you have to do is to bring the name of the file you have assigned. Here we call it stunting. So bring in the stunting, which is this one. As you can see. So once I run this, I'm good to go. Okay, there's an error here. So I need to check what the error is. No such file or directory exists. Okay, so I think I've library that guy. Let me just try again. That is library. Oops. I've done leaflet already, so I don't know. Library leaflets. Okay. Let me try this guy again and see what happens then. Okay, still cannot open. So what would be the issue? What would be the issue? I ran this guy already. Run this guy. Okay. No problem. Maybe I have to exit. There's no error in this at all. Maybe I have to exit but this is a stunt here. It's the same. What is it saying? The file name is not there. Let me try this again. But that's it. It's the same thing. Okay. So let me remind you about something. Sometimes if you run some packages and they are conflicting with others in the system, it's possible that you'll be getting this kind of error, because definitely this is already in, because if this is not in, if I run this guy, I shouldn't get anything. That is this one. I can now close this guy. Let me close this guy. If this is not available, the error is that it's not available, but it's a system error. It's not a correct error, because if this is not available, this should not be showing. Okay, but as you can see, that is showing. So, and it is the same thing that I just moved into this one. That's supposed to work, and in fact, it's not working. So, just hold on. I'm just going to close this session and then restart. Okay. So, all you need to do is to say quit. This is how we quit our sessions. This is how we quit the our session. So I'm just going to quit our session there. Or let me even close my this and see, but I don't think there's any issue here. That is the oh, there are some messages, sorry. Imaria, so that is not I don't know, but the presentation, digital science, the files are in a shape, a zip file that were sent earlier, much earlier, before even the first day that we had our first session. So please, maybe some of your colleagues might send it to you. Yeah, sorry about that. You might have missed up on that. Sorry. Okay, so I'm just trying to close. Don't save. Try this guy again. If it doesn't work, I'll just quit and then come back. Okay, so I need to quit. So quit our session. Save no, don't save anything. You want to save no, just go away. Okay, I'm going to relaunch this guy. Go back. Modeling course, Geospatial. Okay, set my working directory. I need tmap file. And I need to load raster file. Let me just run this once I need now and see how it goes first. So this is loaded. We ran this without any problem. And we plotted this guy. That is fine. We went to the shape file. This is okay. We created this guy here. That is fine, no issues. Same by change the legend. We don't have any problem with that. Now assigning the objects. We don't have any problem with this. And then getting this into the web. That shouldn't be a problem. Yeah, it's working now. So like I said, there's a conflict between some packages. So that's why it's not working. So this one, after quitting, is not working. So the next one, so this worked now. So the next one is to now, so now we are going to the web version. We're now going to the web version. So if I click on this one now, okay, let me go back. So the procedure is simple. Again, as we did before, you run this first. Okay. You run this first. Then we then create the web-based version, which is this one. Then we call the map now. So this is what's happening now. It has not taken you to the web that you can even zoom and zoom out. And then this one, the advantage about this one is that you put Ghana in context. So those who don't even know Ghana, you know that Ghana is along on the right side, you have Togo, you have that, you have that. And if you zoom out, you have more names coming up, Zanzan and all that kind of stuff. Ivory Coast, you see a lot of things around, even to the top. South Center, Western Center, that is where we have the Burkina Faso and stuff. So if you enlarge more, you see a lot of stuff actually. So this is what we call the interactive web-based map. So you can zoom out, zoom in, and zoom out anytime if you're not sure about something. This one allows me to focus on areas that I can see better in terms of the high risk, like these areas. But if you look at a static map, it's difficult for you to do such a thing. Okay. And if I want to see what is here, these these are rivers, so you can expand to see. These are just rivers. So you have the Volta Lake here. As you can see, it tells you what it is. But in the static map, you don't see those names, okay? And even this telling you Volta, eastern part. So only this line divide Volta and the eastern here at this point. And these are rivers, actually. These are located around the river. So these are the beauty about the, what's the name? The interactive web-based mappings. And those of you who want to do this work, which we encourage all of you to move into, this is very helpful. Very soon you see even more interesting stuff as we progress. So this is an interactive web-based version of the map. So you see this as, so this is what you're seeing here, the web version, this one. This is what you're seeing. But because this PDF, that's why it's looking like this. If I were to get this in the Art Studio, like I showed you earlier, I can even zoom out, zoom in, just I'm doing right now. So this is the what we have just produced, proportion stunted, based on the interactive web-based mapping. So you can change even what's the name? The task. These are the tasks. You can change the task if you want. So let me show you how you can change the task if you want as a modeler or maybe a geospatial expert. If you want to change the task, just come back to the web-based version app, this one. Here are the tasks, okay? What we are currently using is the S3 world gray cover. So you see that the background is gray. You can change this to OpenStreetMap. So you see what is happening now? And you can again zoom out, and then now you see even OpenStreetMaps and their demarcations there, how they also represent the water body, everything is there, as you can see. So the programming is once you program, you are good to go. Here it's in this Savannah region, we have East Gonja Municipal District. If it's any other country, the same thing to be doing for you. It will give you the name of the areas and stuff. If you come here to like this OT region and stuff, you realize that they did not produce any estimate for this because these are rivers. So they don't put anything in the rivers. Okay. So those are the things. The system is so, intelligent that it do not do some of the things that we can even do. So the more you zoom out, the more you get to know where the red are and where the lighter ones are. The lighter areas are where the prevalence is low, and the red areas are where the prevalence is high, that kind of stuff. Or if you don't want the OpenStreetMap, you can also change to what's the name? Even if you have a water topo, this one is also another nice one, but it's very defaultive. Yeah, it's very defaultive. So then you have to now decide which of the tiles or the backgrounds you want to use. Myself, most of the time, I'm with the OpenStreetMap because there's a lot of other features like elevation and all those kind of stuff can be shown easily without any struggle. So I like them more in terms of if I want to show certain features alongside my predictions. All right, some charts. Okay, someone is asking the gray color contain missing data. Please no, the gray color, these are rivers. These are where the rivers pass. These are rivers. Okay. Anything you see here, these are all rivers. Okay. So it's telling you that these areas are rivers. So you don't need to go and do anything over there unless someone is living on the river. It's a different matter. All these gray areas that go into it are all rivers. Okay. They are not missing data, they are rivers. If it is a missing data, you see it as part of the scale that is on the right side. These are all rivers, okay? So like I said, there's no missing data here. There's no missing data. Those are rivers. And so to say, can we show names of places in the interactive web-based map? I think we already seen the names. Oh, I don't understand this question. We already seen the names. For instance, even when you went to, I mentioned some even earlier, like this OT region and all that kind of stuff. Or do you say you want to fix a name on it? Like you want to, how will I put it? Like you want to insert a name, or the names are, once you enlarge it, you see the names. But when it's a static map, you cannot insert a name, or you can say a region, but individual locations you cannot. But with the static, with the interactive web, you can zoom out and see specific villages. Very soon you'll see a lot of this. Yeah, somebody's hand is up.
Okay. From what I understand, Doc, we have a raster map there, and below we have got a tile layer, like for example, our OpenStreetMap there. So underneath, that's where we have got the names, and above we've got our raster layer that we have just produced there. So probably I think that explains the name thing.
Yes.
So it means that when we are working with this particular data set, probably because of its set up in a raster format, we can best show it in that manner.
Exactly. And there are other format of data that we're playing with right now, today. This is just one of them. You're going to look at what you call, this is lattice data based on a raster file. We also look at what we call the geostatistical data, which is a point data by index with attributes. We'll look at that, which we even see how we can even create it ourselves. Then we'll also look at the third version, which is actually we creating from Excel file or CSV file and the mapping. Okay, so that's why let's take it one after the other. So what you just said, that's what we are doing. We are doing all this based on the structure of the data. There are others who can do something else, but all of them will come together like what you are seeing right now. So these tiles have the names. So once you get into the web-based version, the tiles have those names, even the street names, the name of the rivers, if there are mountains, the name of the regions, the locations, or even individual towns and that kind of stuff. We are getting there. Somebody is saying, can this be done on Stata? Unfortunately, I haven't produced this kind of sophisticated maps on in a Stata before. All the time I use my R, that's what I do. But Stata is also software just like R. So I believe strongly that depending on your skills set, you can still do this in Stata. I believe that strongly. Remember, most of the time it's not the software, but it's about your competency with that software. How competent are you in using that software? If you are competent using that software, anything you are doing here, definitely I believe you can still do it in that software. Okay. So that is to the person who asked if this can be done in Stata. It's about your competency with the software. Once you have the competency in geospatial modeling and mapping, you can always do this as far as the software is concerned. Okay. There are other people who even use QGIS and ArcGIS and all that kind of stuff. So like I'm saying, it's just your competency with the software. All this can be done. Okay, thank you. Okay, so that is basically about it. And well, though I put it here, this is an assignment that you submit as part of your work. This guy here, I've actually shown it to you. You follow the same procedure we did for stunting. This is for mapping proportion of children who receive all 8 basic vaccinations in Ghana. Okay, and I'm be very generous enough. I've played around this just as we done for the stunting. I went through the same process again, but I want to see how yourself you can bring out something new. Okay, so I want to see how you can polish what I've done here So this is basically the same thing, all right, but I want you to bring some improvement to what I left here. Okay, so this it is a work that you do. And then, like I said, I've already provided all the steps, even the mapping, everything, I've done it. But I want to see if you are able to make some changes to this yourself. That is to get, maybe you want to change the colors, or you want to even modify the scale, or maybe the South North Pole and that kind of stuff. I just want to see how you'll be able to add some few value to this. In fact, I've done the work, but I just need you to do some changes for me to see that, okay, you have gone beyond this to also explore some other way for maybe beautifying the map and stuff. That's all I want to see. So this is an assignment for you, following the same one we have just done. Okay, so this one is also there, the BAS. That is a folder already. You have it in the what I've sent to you. So if you don't know, I can go back and show you. That is this one. That data is in this one, BAS. So you just as we did for this one, you do the same thing for this one. In fact, I've done just a matter of you polishing some of the things for me to have some impression that, oh, at least you have gone beyond this class to also see other ways of beautifying the map. That's all. It can be you playing with the colors or the scales or the north-south pole and other kind of stuff. Anything you want to do just to make changes to what I've done, I'm fine. And I'll mark you based on your genuity, how, genuine you are in trying to modify some of the things I've done. So this is not like you started from scratch. I'll provide it from scratch up to the end already. Just a small beautification of it. We are good to go. So that is for mapping vaccination coverage in Ghana. Now the next bit is mapping geostatistical data. So we have now seen how to map what lattice data based on the stunting outcome. And I've given you an assignment based on vaccination outcome or coverage. Okay. Now, the next data set that we'll be looking at, we call it geostatistical data. So that one, you have information on location, then they add on individual attributes at that location. So it's not like a raster file where the whole area is covered with information. This one, only some locations got data. And the location that got the data in terms of geographical information, they are actually also linked with attributes like maybe stunting, vaccination, and the fact mortality at that location, that kind of stuff. So in this case, we'll be playing with a nutrition again, but this time around is at sample locations randomly across the country. So that data is named nutrition_GH, and it's a CSV file. So let's go to the model nutrition. That is this file. So I'm going to show you something right now. So this is something you can create yourself. This is something you can create yourself in Excel or CSV file like you're seeing. The long here stands for the ID here index individual locations. The long here is a longitude value. The lat here is a latitude value. Here is the total number of children under 5 sampled from a particular location. So for this location 1 here, we are saying 8 children were sampled from that place. And out of that, we say 3 of them were actually stunted. Okay. And the prevalence of stunting is what? 0.375, which would simply be 3 divided by what? 8. The naive prevalence is simply 3 divided by 8 because the total number of children sampled from that location is 8. And number of them who were tested for stunting and were positive is 3. So to get the prevalence at that location, location 1, is simply 3/8. If you're not sure of that, you can check. Just do 3 divided by 8. So that is 0.375. So that's the prevalence of stunting at that very location. How about those who were, this is a weight for AZ score. So this is underweight. Weight for AZ score is underweight. How many of them? None of them. Meaning that at that location, none of the children actually is underweight. But we had 3 of them who are stunted. Okay. Now, when it comes to the prevalence will also be 0 because none of them is underweight. Now, when you come to WHZ, which stands for weight for height Z score, which measures wasting in the population among under 5, wasting. Here too, none of them is wasted. And so the prevalence will be 0. So this is something you can create yourself in Excel or maybe in, so all you need to do is to have the information index with what? The longitude and the latitude what values. That's all. That's all you need. That's all you need. And you do this for all the selected areas in the country or the region or the district that you have collected information on. So in this, in the 2014, we have information on 443 of these locations. 443 locations, that's what you have information on. But the total sample take was 427, so the numbering is not consecutive. So with that one, what it means to you and I is that how do we now convert this information into a special information? Okay, for instance, how easy it is for me to be looking at this longitude, latitude, and then be telling which part they are located in Ghana and what is the prevalence of any of these outcomes. I wouldn't have that opportunity. It's just not feasible. It's just not feasible. But I can convert this information into a map that's easy to see and then to make some decision. Okay. So on that note, this will bring us to the next stage where we are going to, from scratch, map a data straight from Excel. This one we say it in a CSV file, map a data straight from CSV file in R. Very easy process. Sometimes because of lack of skills, some people are tempted to convert this to special, maybe special point or special polygon data from a special point data frame. With the skills now, you don't need to convert that. You can still map directly from the CSV file to what? To special map. So that's the approach you're going to adopt here. So first, I need to read the CSV file I just showed you into R. So this is how you read it. If you want to read the CSV file, you do read.csv. This is not the same as the raster file. When we are reading in the raster file, you saw what we did. But this is a different extension. This is a CSV file. So there's a way to read that one also. And procedure to read the CSV file is this one. Read.csv, then into quote the name of the variable at the data set, and then you have to bring the extension. Because we are sending this as CSV file, you have to add the extension.csv. So you run this one. Then you try to look at the variables in there. So you have the ID, the longitude, the latitude, total, the count of those who are stunted, prevalence of those who are stunted, the count of those who are underweight, prevalence of underweight, count of those who are wasted, the prevalence of wasting in the population. This is what we have seen. So that is back here. If you want to have some good idea, you can look at head also or summary and to do that. Okay, or if you want, this is how you can save this file again. If you want to save this in R as an R file, this is how you can save it. But I'm not interested. But for those who want, this is how you save it. But before you can run this to work, you have to remove the hashtag. This hashtag here in R simply means comment. So if you put hashtag against something like this, if you run it, it will run, but it will not do any work. This one like this is nothing. Though I ran this, but it doesn't take any effect. It doesn't do anything. It will not work because the hashtag means this is a comment. So don't run it like a command. So it will not work. But if I remove the hashtag and I run this one, then only then that it will work. But I don't want to save this. So if you want to save it, you can remove the hashtag and then save it. Just run it here. So let's have a look at what is in there. So these are first 6 observations in the data set, the ID, the longitude, the latitude, and all that. These are first 6 observations. And when you want to have some summary, look at the summary of each of these observations. The longitude, latitude, total here. So you have a minimum number of 1 sample and then maximum of 33. And the mean is 6.172 and the median is 6. And that you have this information for all other variables. Now, like I said, we don't need to convert this to special point data frame before mapping. With the current development, you can map directly from the package, the leaflet package, or any other package that you're competent with to produce your map directly. So that's the strategy I'm adopting here. Even though if you look at the stunting prevalence, you could see that it ranges from 0 up to what? 1. 1 means 100%. 0 means 0%. You can multiply these values by 100 to produce the map in terms of percentages. But you can also keep it as it is now and produce it in terms of what? Proportion. Okay, proportion. And that's what I've done here. That's what I've done here. Maybe after this, I can show you, I can do another one down here to show you how you can do that also as a percentage. It's not a problem at all. So here, I need to define colors that I want to use. There are different set of colors in R that you might want to use. You have the viridis, which is very common. The Parma and several of them are there. So at the end of the day, you have to decide which of them, because this is what I normally use most. You can use the blues. You have the blues also, where everything that they produce will be in blues, from the lighter blue to deeper blue. You can also have the rainbow color also. It's also there, but most of the time I use the viridis color. You can also try. It's just a matter of changing this name here and everything remains the same. So this is just creating a color palette so that these are colors that this time we used to do the map for me. Unlike the earlier one we did, where this time is determine the colors here and there. With this one, we have that we can decide which color we want to use. That one too, we can decide the color, but we didn't do it. But here we can do it. So first, this is the color I want to use. But this color. Okay, he's telling me that I cannot locate this one. So there's a function called color brewer. Then we also have another function called, there are different functions that we normally use. This one, where are you? We already ran leaflets. Okay. So leaflets. Getting some call. So of library. Leaflets. So we go back and then run that. So that worked now. So all we need to do now that we define the color to be used, the next thing we need to do is to run leaflet, bring the command leaflet. That's the name we have given. I mean, the one we loaded, the part we loaded, leaflet. Then the name that we gave to the data, which is NUTR from here, from this part. We just have to give the name to the function here. This is a pipe, that's like a loop. That's if you're doing things continuously, you don't want to give a break. This is what we use in the R. It's a pipe. We call it piping. Or maybe somebody say looping. And I don't know. They're not necessarily the same, but they are similar. How you do loop, you keep things running in the same order. You don't want to give a break. But here we call it pipe. Okay, this is what we call pipe. So meaning that after you look at the data, it should add on the provider task. That's which tab you want to use. Is it the Google Street Map or something, or OpenStreetMap or something? Is that one you have to specify? After that, we are saying that, okay, what are the location information? That's the longitude and the latitude. What are the location information? So that will come after the R circles. So we say the longitude is named this, and we say the latitude is named this. This is how we named it in our data set. If you check the data set, that's how we named it. Then which color do you want to use? We say PAL. So that's one we define here, the color palette. So any color, any name you give, you can even give a PO or anything, any way you want to. Me, I just call it PAL because the name is palette. So I just use certain is PAL to know that this is my color palette. Then what do I want to map? I want to map the prevalence of what? Stunting, which I named prev_HAZ, where the HAZ stands for high for AZ score. And then what you're seeing here is the name of the data set. So I'm saying, what I'm saying the same is that go and look for this data set. And inside the data set, there's a variable called prev_HAZ, which in our case represents what? The stunting prevalence. The stunting prevalence. The add legend. Do I want to add legend? I say yes, add a legend. I say put a legend at the bottom. And then The color palette I want to use is called PAL, the one we define. And what value do I want to use for the PAL? I say the value should be based on the prevalence of stunting. The value should be based on prevalence of stunting. The next thing is, do I want to add title to the plot? I say yes. What name do I want to give to the title? I say proportion stunted. Proportion stunted. Then the pipe continues. Do I want to add a scale bar to the map? I say yes. Because once you put the position equal to something, that means you want to add it. So I say yes. So where do you want to put it? I say bottom left. I say put the scale bar at the bottom left of the map. My people, with this, we are good to go. We have succeeded in producing a map straight from a CSV file, something that we can even enter ourselves and then use. So if you go to the field college, they can just enter into a CSV file or Excel file, CS as a CSV, you are good to go. If you can see as an Excel file also, it's just a matter of reading the file as Excel, and then you are good to go. If you see it as a CSV file, when you're reading the file, you have to read it as what? CSV file. That is all. Nothing more, nothing less. So with this, about 1, 2, 3, 4, 5 lines, you're on the way to produce a map based on a raw data from CSV file. So let's see how it goes. Can you see the current screen?
Yes.
Yes.
Good. So you can see that straightforward, you are able to produce a map for geostatistical data at a point. And then we're able to map the prevalence at each of those points. So the circles are the area they sample the data from, the children from. The circles represent where children are sampled from. Then the colors for the circles represent the prevalence of stunting at those locations. So if you look at this one like this, let's be here. The yellow one here, if you look at the prevalence of stunting, the yellow one here, yellow means worst scenario, ranging from 75 to 100% stunting in that location. So children sample from here stands a higher risk of being what? Stunted. That's the meaning. Compared to this one, where it is how do you call it? Is it purple? It is purple. Do you call this purple? And I'm not good in color, so I think it's purple. So the purple ones are the ones you have in terms of low prevalence. They range from 0 to what? 25%. 0 to 25% stunting. So those are the lower prevalence areas. You see? So you have those in the green, something around Nkonta here. This one like this is in the green. So those ones range from 50% to 25%. You see? And here you can see that the names, the rivers, even here is most, you see that this is geostatistical data, so it's not a rastered file. You realize that a lot of names can be seen in a very, very smaller towns. So here like this, there's a place here called Pasa. Those of you who are from Ghana, you know where Pasa is. All these things are there. So these are easy for you to locate to see which towns are closer to where the high risk are. I hope you are following. So again, here, this Kumasi. And within Kumasi, you can see a lot of towns, Bantama, Edum, Assam. I mean, all those are there. And these are things you cannot get from the static maps. Okay. So from a CSV file, which you can create with your own hands without any issue, straight to mapping, without the need to convert this first to what? Special data. But there's a way you can convert this to a special data, which would be what you call special polygons data frames. No, special point polygon data frame. So this one like this is a point, so it will be special point data frame. When you have the polygon like districts, several districts in a town or region, that kind of stuff, then you have to call special polygon data frame. So I can convert this one from CSV file straight to what you call special point data frame. Special point data frame. That can be done with ease. Somebody is saying she don't understand the leaflet package that I ran. So I'm saying that with the leaflet package, we can run data directly from CSV file or Excel file once we load it into R. Okay. The first thing you need to do is to define colors for the map you want to plot. Define colors. And I've explained that there are different types of color palettes. But normally, I normally use the Viridis color. And I mentioned that you can also think about other colors like the blues that will do the blue from lighter blue to deeper blue. You can also do colors like, how do you call it? Is it Rambo colors? You can also do Rambo colors. For instance, if I want to change this one, I can change without any struggle. But let me just create a new one. I can change this to blues. So that I want to use blue color. So we can change this to blues. And I run. So when you get here, I say for the leaflet, all that you need is the name of the data set that you have. We save our data set as NUTR, which is the nutrition data. This one, this is how we save the data set in R. In CSV file, this is how we save it. But how we are reading it into R, we give it another name, which is this one. This is what we gave to in R now. And to map, you need to bring the same data set name here in R. So you have leaflet function that you put R. This is a piping, and I'm saying piping is similar to what we call looping, where you want to do things in multiples. You don't want to break. You don't want to finish one before going to the other. So this is what we use in leaflet. So I say after that, just add the task. The task we are seeing right now, the one we are seeing on the website. That's the web version. These tasks we are seeing, I ask the system to produce these tasks for us. I ask the task to be added from that part of the function, which is this part. If I don't specify this, the system can give me anything, either I like it or not. And another piping, meaning that I'm continuing the process. The next one, I say add the circles. Add the circles here, we're talking about the latitude and the longitude coordinates. Now add the coordinate to the map. Get the coordinate for me. And I'm saying that coordinate, I name them longitude, I put it this way, and the latitude, I put it what? This way. And this can be seen here. If you come back to this, this is how we assign a name to the longitude, and this is how we call what? The latitude. So the name that you have assigned to the longitude and latitude, you have to put over there. That's what you need to use here and here. This is just a tilde sign. If you want, you're doing linear regression, if you're running linear regression in R, you say LM into bracket, then you bring your outcome variable, then tilde sign for the independent variables. It's the same tilde sign that we're using. Then what color do you want to use? I say I want to use my palette, which is this one I created here, the one with any of these that we created. And what's the name of the data set? Is this one. What do I want to map? I say is what? Prevalence underscore -AZ score. Then do I want to add legend? I say yes, add legend. Where? I say bottom. Which color do I want to use for the legend? I say just the one I created, the power one, the one, any of these that I created. What value do I want to use for the legend? I say the values of the prevalence of stunting, which is the prev underscore HAZ. Do I want to give a title to the map? I say yes, give it a title. So what title do you want to give? I say proportion stunted. Proportion stunted. Do I want to add a scale bar to the map? I say yes, go ahead and add a scale bar to the map. Then they're asking me, so which position do I want them to place the scale bar? I say put it at bottom left. Bottom left. Place it at bottom left. So that's what I've done here. And my job is done. Once I'm done, all I need to do is to run this one. Remember this time around, I'm using blues. So the colors will be from lighter blue to deeper blue. It will not be the one you saw earlier. So do you see? So you see now?
Yes.
So because I specify blues, it will do that from the lighter blue to the deeper blue. It has changed the color. It has changed the color. All of the previous one we did, which was where are you? Oh, come on, move away from here. Sometimes this come and then just block everything. The earlier one I did, look at the colors we used. These are colors that we used. We change the colors now to blues, so you have this one. So they can change the colors to rainbow. And some other ones, several of them are there. So depending on the work you're doing, you have to decide appropriate color for your work. Okay. In fact, even this one like this, the first one like this, someone will say, oh, purple, you should let purple rather represent the higher prevalence and yellow represent what? The lighter prevalence or the low prevalence. So why not swap it? It's allowed. It's just a matter of commanding the system to behave as such. So in that case, this is why we did this, and you want to revert this one. Sometimes some of the packages appreciate that, but others don't. So let's see if this guy will appreciate it. So we normally use a function called reverse equal to true, meaning that if it is if the lowest one is purple and the highest is yellow, you want to swap it so that the yellow will now represent the lower risk and the purple will represent the higher risk. So some packages accept this kind of reversal. So let's see how this one will go, just so we can compare. So here in this case, we want the yellow to be the lower prevalence, and then the purple, the deep purple should be higher hot prevalence. So that's what we are looking at now. So this is what is happening right now. So if it has changed, reverse actually. So now the yellow now represents lower prevalence and the deep purple represents what? Higher prevalence. So why now you see purple, you're talking about where the higher prevalence of stunting can be located. And where you see yellow, you're talking about where the lower prevalence of stunting can be found. That's basically about it. So you can play with the colors, anything, just to make sure you fit the purpose for the day. That's all. Okay, on that note, we can continue now. Again, exercise for you again. So using the CSV file data name nutrition_GH, address the following. Produce map for the prevalence of wasting, which is a prev_that variable, and also produce map for the prevalence of underweight, which is prev_WAZ variable, which you can see here. And I know nobody will come and say, I could not find it. Those things are here. The prevalence WAZ is there, and the prevalence _WO. It's just a matter of following the same course, just change a few things, you are there. Okay, and also try to see if you can make your own changes and stuff. That'll be very interesting. Okay. All right, so that's it. Very soon I should be wrapping up anyway. So the next thing is, okay. So when you say, okay, I go to the field, I collect the data for maybe regions in my country, or in Ghana, regions in Ghana. But I have a data separately from Ministry of Health or Ghana Health Service, talking about COVID-19 cases in Ghana by regions. But I have a shape file for Ghana where that information is not there. How can I get the information from Ministry of Health or Ghana Health Service on COVID-19? How can I map that using the shape file that I will get for Ghana, regional shape files? So that's the next assignment that we have to do right now. So if you go back to your the folder that I sent to you, there is a folder there called Ghana Regional Boundary, this one. And if you open it, you see these things in there. These are what we call shape files. These are what we call shape files. This is just one shape file, but you need all of this to be present before you can read it correctly into the system. If I remove any of this, this system, the shape file will not work. And the actual shape file that does the work, or that will do the work, is this guy, the one with the extension .shp. .shp is the one that will do the magic for us. But if any of these other ones are absent, this guy will not work properly. Again, what you needed to do the action plan is the one with the .shp. If you watch, all of them have the same name. It's only the extension that is different. It's only the extension that is different. But the one that actually carries the shape file itself is this one, the one that have the .shp. But if any of the other supporting files are absent or are missing here, your shape file cannot be read correctly for use. So take notice of that. So when you download and unzip your shape files, make sure that you keep a folder for them, because everything in that folder have to be there before the shape file can work. Else you complain that your downloaded shape file is not working. It's just because you might have done something wrong. This is what most students do most of the times. Even when you do the training, you tell them this. When they go back on their own, they're doing their own work, they forget this and then they copy only the one with the .sch, thinking that they can read that one into the system. You cannot. It will not work for you. So the whole of these shape files components have to be there before you can read the shape file itself into your work. Okay. So in our case here, the package that we normally use to read the shape files, we call it the algida. Algida. That's the package that we normally use to read shape files. Shape files are simply a special data set that are stored in a particular format called shape file. Just as we have the raster file, we also have a shape file. How do we read a shape file into our system? There's this function, you need a function called, let me put it here. You have to first library. All these names are at the top already, but because I'm loading the one by one so that it doesn't conflict the earlier one, so I'm loading the one by one. You have a package called, come on, library into bracket, algida. This is a guy who will do the magic for us. We need to load this package to be able to read the shape file into our system. So you run that one. It gives you a lot of stories. It's even going to tell you that not long to come, they will terminate this one. You have to use another version, another type. It's not a problem for us at all. So this is just some notes for you to know, but it has loaded correctly. So one that is done, just as we did in the case of the stunting, reading of the verb for stunting, you first have to go and grab the folder in which the files are saved. So in this case, I'm going to grab this guy first. This guy, I have to grab this guy first. I need to grab this guy first, which you have seen there, which is this part. Then the second part, I can grab any of these because these ones are the same. I don't need to bring the extension. Remember, you don't need to bring the extension for the file itself. So I'm going to open the file now. You see all these things here, they have extensions, but you don't need to add the extension to the file. Just, for instance, I can copy even this one, and I'll copy only this one without the extension. The moment you add extension, you are in trouble because you don't need the extension. If you add the extension, it will give you an error. Just copy the one without any extension. So because of that, you can copy any of them. Just make sure you don't add extension. And then when you come here, just paste it. Just paste it here. Please, your job is done. And the function to read a shape file is read OGR. That's a function which is coming from the algida package. This is coming from the algida package. So let me say read shape file into R using algida package. They are at the top anyway. I indicated those two at the top already, but maybe just for ease of reference. The algida package. So the algida package, it is this function in that package that helps us to read the shape file. So if I run this line right now, the shape file, the original polygons of Ghana are supposed to be what? Loaded for me. So if you look at this, this is telling me that with 16 features means 16 polygons. In special, if you hear about features, it's about polygons or special points. So when they say 16 features, it means there are 16 polygons. And it is true that in Ghana, there are 16 regions in Ghana at the moment. There are 16 regions in Ghana at the moment. And then it's telling that it has 9 fields. Now fields in special simply means that variables. variables, meaning there are 16 polygons with 9 variables in it. We are going to check ourselves. So that's basically about this one. So let's check the class of this. This is telling you that this data is a special polygons data frame. Special polygons data frame, meaning that it's a special in nature, and these are polygons, and it has data set inside it. So 3 things. This is a special data made up of polygons and have data set in it. That's the meaning. Now, the next thing to do is to plot to see if indeed we can have a look at the regional map of Ghana, if that's what we actually loaded. So you do that one. So you can see the polygons demarcating Ghana per the regions. Okay. So this is what we want to see. We want to see all the 60 regions represented in Ghana because that's a shapefile we have loaded. So this is telling you and I that the shapefile we have loaded is correct. No problem at all. We are good to go. Sometimes you might want to see which either it is in the degree or meters in terms of the coordinate, either it's in the degree or meters. You can check that. So what do? You just do the same plot again, bring the same regional data, then you add as is. As is simply means that I want to know what the longitude and latitudes are. So just add T stand for true. T stand for true. Do I want to add as is? I say yes. I can say false. I can say yes. So this is for yes. So look. So do you see what I'm saying now? So this is 4 degrees to the west, 3 degrees to the west, up to 2 degrees to the east on the longitude. This is a longitude part. So this is telling that this is in degrees. This is telling that this is in what? Degrees. On the latitude part, you have 5 degrees north, 6 degrees north, all the way to what? 11 degrees north. So, you know, we talk about these conventions and other things. Very soon, we'll learn how to convert these to what? Meters. We'll soon learn how to convert these degrees to meters, like we discussed in the tutorial the theoretical session. So don't worry. So once you do as is equal to true, it will display the longitude and the latitude values for you in degrees. So this is telling, once you see this thing, it's telling that this is in degrees, not in kilometers or meters, it's in degrees. But this can be transformed or projected into something else that we can have it in the form of kilometers or meters. By default, it goes into meters. Okay. So if you like, you can have a fill of the data by looking at the head first 6 data points. That's it. But if you want to see that the special component, then you have to do summary. To see the special component, you need to do summary. So I can just do summary. Then rec. So here you see object of class special polygon data frame, and it's talking about the coordinates. You see the minimum coordinate on the x-axis, which is longitude is -3 point that, and the +1 point that. Then the minimum on the latitude, which is y, is 4.7 something, and the maximum is 11 point something. And either it is projected or not, they say 4, this is not projected. Okay. And it gives you some variables. So they say, if you remember, they say there are 9 features. So you have the variable name 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the features which you call data attribute 9. So that was correctly reported. Now, the task now is to, now we have the polygons, but without the COVID-19 data. How do we get the COVID-19 data into the polygons and map? That's the whole strategy. There are 2 approaches. You can extract the data component from the special map, from this shapefile, and then look at the regions in there and then assign a new column as a value. Again, just extract the data component of the shapefile, because over there you see the name of the regions. So once you see the name of the regions, just now enter, because it makes it easy for you so that you don't give some value to another region. So extract the same shapefile data set and then create a third column or another column where you see COVID-19 prevalence or COVID-19 figures. Then you enter it per the 16 regions. Then you save that. Then you read that one back into the R again, and then convert that into shapefile again. Or you merge it with the existing shapefile. That is a long process. That is a long process. So what normally I recommend is that you can still be within the data set like we are here together with the R. Then what we need to do is to have the COVID-19 figures and create a data set for that only within R right now. And then what you do is that we now add this onto the shapefile, which is much easier, much easier, because saving it as a CSV file and then going to enter the data manually and coming to load it back into R and trying to merge it now with the existing shapefile and stuff can take a time, and sometimes you can make a mistake. But for this one, all we need to do is that in the data set, how do they come? Which one come first? Which one come second? Which one come last? Then we just assign the values per how they appear in the data set, and our job is done. So that is the approach that we'll use. We'll extract the data set and see how they look like, which region comes first in the data set before the other. Once you're happy with that one, we are good to go. So that is what we do in the next stages to come. Merge, not the merge one. So, but I've given you the two scenarios where you can save it as a data set. For, okay, let me show you briefly. Maybe some of you might want to go that way. So this one. So here I'm extracting only the data component. When I bring the name of the shapefile and I say at data, I'm telling the system that I just want the data frame, not the shapefile, only the data frame, which means those 9 observations. That's what I want. I don't want the shapefile itself. No, I want only the data component. So if I do this, you see this one. So it's not data frame. It's no more shapefile. So if you want to be sure, just do data and then call. So you see what is happening now. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 features that they say they have. But what is of interest to you and I right now is this one. Name underscore 1 is for region. So these are region names. Name underscore 1 is for region. Now we need to go and find out how the regions are arranged. If you look at this one, the first region, the one that appears first in the data set is Ashanti, followed by Bono East, followed by Central Region, Eastern, Greater Accra, Savannah, Upper West, up to the last one, which is what? Western North. So all I need to know is to see which of them come first or which in that order. So that when I get a figure, if I want to Ashanti region, I want to region the first one, so I'll put it for the first one. Bono, I have to go and look for Bono to be the second, Central to be the third, in that order until I finish all the 16. Okay? So that is all I need to do. But if you want to go the other way, then I can save this data. I can save this data as a SATA file or as a CSV file so that I can go and open it manually and then manually enter the figures for each of these regions, because by then I will see the region I enter, But like I said, at this level, that is at a much lower level. We don't need to do that. But that is the step. If you want to follow it, you can follow it. Then after that, you need to read it back. So I follow that step to do it. So as you can see, when I went in there, I went to create a data in CSV file called data.csv, and then I do it manually. So I come and read it back and I give it this name. And then over there, I now come to merge that one, so this is a shape file that we already read earlier. And this is what? The new one that we went and fixed manually. And how do I want to merge them? Which is a common, or what are the common variables? I say the common variables are name underscore 1, name underscore 1. In fact, I can just do by and then provide this as 1, this one. I can do this one also because the names are common. So I don't need to separate them. So any of this is fine. But again, this is for the basis, very, very fundamental. So let's go and look, do what is appropriate at our level now. So instead of doing all the things I explained earlier, I can just arrange the values according to how the regions appear. I'm not certain region is back. So in the for example, from Ghana Health Service or from Ministry of Health, the value for certain region is 22,286 for COVID-19 cases as at the time we are looking at. And that time for this data, that was at the time, I put the date somewhere. Mapping, yeah, that is from 12 March 2022 to 17 February 2022. That's the data that you are seeing here. Number of COVID-19 cases in Ghana as at that time. Okay, so in that report, this is the figure for Ashanti region. This is the figure for Bono East. This is the figure for Central region. Up to the last one, which is for the Western North, which is for the Western North. So once I've done this, what I've just done is to assign a name, which I call confirmed cases. Confirmed cases. So I create that. So if I run this one, and you want to be sure that this is properly captured, I can just run this guy again. And you are there. It is captured just as you presented it. Now, the next thing, what I did here is to compare this one to what I've just done, but I have not run this one now, so there's no point to waste your time here on this one because we are using the second procedure. So right now, what it means is that we need to now add on this data we just created to the shapefile. Now, in a shapefile, for you to read the data set, you have to do at data like we did earlier. So that is this component. The shapefile is reg, that you know. Then you have to bring at so that you can access where the data sets are stored. So the whole of this part is only telling you that, it's only telling us that, please, I want to access the data in your polygon or in your shapefile, not the shapefile itself, just the data. But while I've accessed the data set, I want to add on another guy called confirmed cases, which is this part. So what it means is that we are now creating a new variable in addition to what is already in existence. Earlier, we are aware that there are 9 variables. So when we finish this one, there will be 10 variables now. So they will now add this one onto the shapefile for us. So in a way, we have now combined the shapefile information together with what we have just created. And we will now have one shapefile data. And that's all we need to progress. That is all we need to what? To progress. So I'm going to run this one now. So we are there. Here, I just want to do some changes to the name so that I don't repeat the old name. So I just rename, it's not a rename, I'll just reassign another name. Instead of having a rec only, I now have rec underscore data because now I've added on a new data. So just to differentiate. So I run this one, it's the same thing. It's just the name of changing of the data set name. That's all I've done. I didn't change anything. So if I now run this guy, maybe for better understanding, I'm going to run the whole of that. The data part. So, okay, let me do this for you first so that you know the class. Because this originally special polygon data frame, even when you now add on new variable to it using the procedure we just used, it will still be the same special polygon data frame. So do you see? Special polygons or data frame is the same. Now let's see if the variable we created is there or not. So you see, confirmed what? Cases. Confirmed cases. So this one, they just pull out, Aheto and the Western North for us. They pull out Aheto and the Western North. But we now have to go and check if indeed these are correctly presented. So the easy way out is that we'll call out the data set itself and see how it will go. And how do you call out the data set itself? So we can do the same thing, all right? But now we add at data so that now we are only calling what? The data frame without the special polygon. So let's go. So it will produce all the information for us. So you see, we are here now confirmed cases. So 222 ACs, which you know for Ashanti, the same thing. The 111109 we know for Western is the same thing. It's the same thing. And 111134, I think that is for Aheto, is the same thing. So no trouble at all. We are good to go. That's the meaning. So now if you want, why not? You can save the data now. I have saved it already, so I don't need to save this again. You can save it. And then anytime I can make a reference to it, no problem at all. And then also, if you like, you can look at the summary of cases. This is just for summary of the case, confirmed cases. So minimum is 291 and the maximum is 88425, which is in Greater Accra. Okay. Now let's start mapping now. Now you guys are expert in mapping, so even you can do this on your own. We want to map this using the team map again. So here, first I assign a name for the map I want to create. And as usual, you know, you have to just bring the name of the data set first. And then here, because this polygon, this is no more points, so these polygons. The first one we did is lattice data, so we don't put a polygon. This is a polygon, so you have to put the polygons. And then here, you don't need to do call icon to this again, because this is not a TIFA raster file anymore. It's a special polygon data frame. So here you don't need to do caller or that COL equal to, you don't need that anymore. So just put the name of the variable you want to map inside the quotation, then plus, then do you want to insert the name of the regions? For instance, what this will do is that it will produce the map of the confirmed cases and then add on the regions. But if you don't want that, you can do first without the region, then you can do second with region so that you know the difference between the two. So I'm going to take away this component here, meaning I just want to map the region with the count, with the original name embedded on it. So you go. So now if I want to call the map, I will have a W map. I'm going to maintain this for some time. So do you see? Please, can you see the map?
Yes, it's visible.
Yes, you can see, yeah.
But this is not looking good because this is the what we call the natural default method. Again, look at where they place the legend and the name of the legend and even the color system. Okay, apart from, so there are only 3 colors at the moment. The one in the Greater Accra, Ashanti, and then others have the same. But the rate is not the same across the others like we have seen. So we could have partitioned this in a more reasonable way so that we can differentiate the differences within the count of COVID-19 within the period. So this, like I said, this is a default. Another way is to insert the name of the region inside for those who might not be a good geographers who can easily tell which part of Ghana is this in terms of regions. They can easily look at it. So that's the second bit of it, which is this one. So this is where we insert the name of the regions. And all that we did is to say TM_test. So we say insert the name. And name_1 is the one that carries the name of the region. So that's what you're seeing. So you can see now. The upper east, north, upper east, Savannah, northern, OT, Bono East, Bono, Aheto, Ashanti, Eastern, Water, Greater Accra, Central, Western, and Western North. Everything is there for you. Okay. So you have the name of the region inserted and then the prevalence of or the count of COVID-19 in there. But like I said, you can also get this one into the web version, which we tried earlier. And the fancy, the only fancy you need is a tmap_leaflet. This is what you need. Then you bring the name of the map we just saved, the one we created. So if I run this one, this will take us to the web version aspect. So again, that. So you see, again, you can, like I said earlier, you can change these styles. I can change from here to maybe Open Street or to the World Topo map. Any of them is fine. By default, the same will produce something like this because that's what we provided. Now let's try to improve upon these maps. Yeah, the values in the vector are in the same order as the regions appear in the data set. And I've explained that already. And if you have many polygons, this is the best approach, because doing the manual imputation on Excel file or CSV file will take you more time than this procedure. It will take you more time than this procedure. But if sometimes the data set is already captured in Excel or maybe any other statistical package form, then what you need to do, you can make sure that the way the regions are written in the polygons or in the shapefile, you adjust the name of the regions in your new data set the same way. I mean, how they are named. If something is capital in the shapefile and you make it small letter in your data set, it will not help in combining the data set. So if you know you have a lot or maybe thousands of observations that you cannot do what you have just done, you have to make sure that the name of the region as it is in the shapefile, you program your new data set to conform to that name, both in letters and even in writing. This you agree. Secondly, you should have a variable that is common to what you have in the shapefile and what you now have in your new data set, so that you can use that one to do the merging. Again, I'm saying because somebody say you have a large data point here and there, what do you do? That is only approach you can use to overcome that, by merging. Make sure the name of the regions as appear in the shapefile is the same as it is in your new data set that you have, that you want to put together with the shapefile. Secondly, make sure you have a common ID that appears in the shapefile, and the same ID also appear in what? Your new data set. So that you can use that common ID to merge them. You can merge a shapefile with a data frame, no problem at all. Once you read them into R, you can make them easy. But make sure that the name of the regions as presented in the shapefile, assuming the variable you're interested in is a region, the name of the regions in the shapefile remain the same as it is in what? The new file that you want to merge with. And that you have a common identifier that can link both data sets together. That is the shapefile and the data set that you have together. And with that, there's a command called merge in R. You just use the merge command to merge the data set, just as I've shown you in terms of merging two data frames. We can also merge polygons, or maybe let me put it this way. We can also merge shapefiles with data frames. That's all. So it's not a problem at all. Okay. So yeah, so here we try to improve upon the map small to see how it looks like. When you go, you can play around this yourself anyway, but I just put this here. You can play with it. There are different ways. So we're trying to improve upon the maps by giving our own cutoff and stuff, and also allowing for the histogram and many other. Even you can do that by contrast. You know, contrast, try to make sure things are equal. You can do that by contrast also, but sometimes the contrast can lead to a very skewed kind of situation. So here too, we just decided to put a different category to see how it looks like, and then get into the interactive web-based format. Something like this. It's looking a bit better than before. At least there are some kind of, we begin to see some variabilities in the count of COVID across the regions, that kind of stuff. So that's all about it. Nothing more, nothing less. And like I said, all this I'm talking about is here. They are here on the PDF. All of them are here. All you need to do is to copy the command, run, copy the command and run. And then just make sure you follow everything. So all the steps, like I said, so this is all you have just done. And then I've shown you some of these things. So I'm now going to go straight to mapping and birth attendance in Nigeria. We have heard so much about Ghana. So let's move away from Ghana also. This data set is also based on we want to map skilled birth attendants in Nigeria. So the same process we did for the stunting, the same thing, there's no difference, the same thing. Just as we also did for others in leaflet. We use a leaflet package also. Someone is asking, can we extract one polygon to find what's happening there and there? Oh yes, you can extract it, no problem. Fortunately, I discussed that at that time, so it's part of the assignment I'm doing today, so we'll get there. You can extract a single polygon or 2 polygons or maybe more. And somebody also sent me a message asking if you can combine countries or let's say polygons or other things together. All those things, I've incorporated them in the new PDF that they have sent you today. So yes, we are going to do those things, so don't worry. Okay, so the data set I call D. So if you look at where are you? If you look at you have this data set called D here. That is the one that contains skilled birth attendants in Nigeria. It's also the same thing, just as I've shown you earlier. The same procedure, you see. So you have the DH cluster ID, X and Y. Here, the X is the longitude and the Y is the latitude, as you all know. Okay. So you can give it any name at all. The longitude or latitude, you can give it XY, it doesn't matter. And again, we have total number of children sampled, The SBAP is the prevalence of skilled birth attendants. And this is in percentages. You multiply this one by 100. That's why we have it in percentages. So this is in percentages. These are in percentages. These are in percentages. Skilled birth attendants in percentages. So this is what we want to map. And our longitude and latitude are simply the X and Y. So we need the X and Y. And we need our SBA underscore P to be able to map this. That's all we need to go. So first I need to read in that variable in CSV file, which is the SBA. So I call it SBA, which is skilled birth attendants. I call it SBA. And I read that one. So these are the things you have seen already. So we have the X, we have the Y component, which is longitude and latitude. Then we have what you want to map is skilled birth attendants present, the one with the P. Skilled birth attendants or present. That's what we want to map. So the same procedure again we did for the stunting. So we need to declare the color palette, which is this one. And then as usual, if you go by, it's the same thing. So the name of the data set is SBA. The name of the color palette, we need it, which is this one, PAL. And as you discussed, you need the longitude and then the latitude. This time around, the longitude we use S to represent it, and the latitude we use Y, as you can see in the data set. So that's only you put over there. And then this one is asking you, what do you want to map with the color? You want to map SBA underscore P, which is percent of children who are the skilled birth attendants. That's it. And then do you want to add legend? I say yes. As usual, I say bottom right. What color do you want to use? I say PAL, which are defined at the top here. And for which values? I say SBA underscore P. Do you want to add title? I say yes. How do I call it? I say skilled birth attendants percent. So this in percentages, not proportion. Do you want to add a scale bar? I say yes. Where do you want to put it? I say put it at the bottom left. Bottom left. With this, my job is done. So I can just run the whole of this now, and that will produce you another statistical data at the point location in Nigeria. So if you have some Nigerians on board here, they can tell us if this is a shape of Nigeria. So what you're seeing here is a map of Nigeria showing skilled birth attendants. I can bring it closer to the distance so you can see here. This skilled birth attendants in Nigeria. And then the lower the prevalence, the deeper the red. And the higher the prevalence of skilled birth attendants, the blue, the deeper the blue, as you can see. So what you are seeing, the deeper blue area, these are areas where there's a high prevalence of skilled birth attendants. And when you are seeing the red, these are the areas where there are lower prevalence of skilled attendants. So if you look at the northern part of Nigeria, there seems to be dominating when it comes to not receiving skilled birth attendants at birth. That's the meaning. But if you look at the southern part, generally, and somewhere in the middle also, generally they appear to be those who are leading in terms of receiving a lot of or delivering with scale of attendance, that kind of stuff. So easy. When you look at these things like this, it's easy to make a decision. But if you look at the Excel, the CSV file I open for you right now, you can hardly make any decision out of what is here. By converting this to this map, you can see how meaningful this is to us at this time. And this is coming from the 2018 Demographic Health Survey for Nigeria. So this is a real data. This is a real data set. It's not anything cooked from anywhere. This came from the 2018 Nigeria Demographic Health Survey data. Okay. All right. So now, the next one, which somebody just asked, subsetting polygons. Maybe we have regional polygon for Ghana, which we just played with, which is this one. These are the regional polygons of Ghana. And then maybe we wanted only northern region. We want to extract, this is a northern region, this one. This is a northern region of Ghana. This is a map. This is a polygon for it. We want to extract only this one for work or for some analysis, or maybe for more kind of contextual kind of work. How do I separate this one from the entire system? How do I separate this one? It's very easy. So I want northern, so I just provide a name. You can call it any way you want. I just call it northern because that's the one I want to extract. Then use the command subset. Subset. It's a function that we use to subset data sets. We use the same also in shapefiles also. Remember that the class of our this is a shapefile. If you forget, you can always check again. This element here is a shapefile. It's not a data frame. So be careful when you are subsetting things of that nature. You need to be careful, know what class they are. This is still our special polygons data frame. As you can see, special polygons for data frame. It has not changed, it's still the same. So in order to pull a particular region or polygon out of many, identify the variable that represents the names of those polygons. Name underscore one is the one that represents the regions in Ghana. So call that variable. Then bring equal, double equal to sign. This is double. Bring the two. Then put into quotation the name of the region as it will appear in the shapefile. Again, put into quotation the name of the region as it will appear in the shapefile. So if you want to be sure, I can call this again, just for you to know how the regions were named. So you can call this one and do at data. Then you go under the regions. We say we want northern region. So this is is captured. See, and then name one. So name one is the one that hosts all the name of the regions in Ghana. So under name one, how is northern region named? It's named northern. If I change any of this, I'm in trouble. So if I come here and I change this to small letter, if I run this, will not work. Plus, you can imagine. Okay, so I can see the NAs. I can see the NAs. As you can see, NAs. Because this is not properly loaded, because this is supposed to be hot. Though it ran, I was worried because I'm surprised that it doesn't throw any error, because it's supposed to tell me that you cannot find that because it's capital N. But when you move on and you find summary for northern, you realize that performance cases are assigned hot, nothing. But I can still see the polygons there, meaning that it must be loaded. So let's do the plotting for that and see. Let's do, if the plotting works, there might be, I don't know what happened here. So let's see the plotting. You see that it did not work? It did not work because that is not a name. And then we use the capital one. So let's see the capital one too. Where are you? I'm surprised this one will work. And truly did not work. And I'm happy because we did not specify the name correctly, like I said earlier. So this did not work. Now let's specify the name correctly and see. So yes, this is supposed to be what? Capital. Okay. So you do that one, you do class, you do summary. So you see that confirmed cases now have values for northern region. so that it repeat the same numbers for another region because it's the same region. So the number will not vary. Meaning that if you check for another region, the count for another region is 1,063 COVID-19 cases. So this is what we want. And from there, if you like, you can now plot and see if that is correct. That is it. If you want to know this is indeed correct, we can do another plot. So you have your XX. Oh, come on. Can do another side-by-side plot for the same thing, and now you see. But this time around for the whole of Ghana. So try to look at the shape of the northern region in Ghana. This is another region in Ghana. Look at this shape. If you come here, does it look the same? Does it look the same, or you think there's a change?
Yes, it does.
That is it. So any other part you want, that's all you need to do. Sometimes you're doing a study, you want to use about 4 different regions, but not all the 16 regions. You can pull them out individually, then you combine them. And that was a question I got from somebody. The same also applies to a country. If you want to combine maybe countries within Africa, but not all of them, but just some of them, you can pull out those countries using their names. That's what we did for the region here, the same approach, using their names, the country names column, and then put the name of the country as it is, and then pull them out individually, then save them one by one. Then when you do that, you can now combine all of them. That's the next stage, so don't worry. So so those who are asking, can you extract a particular polygon and maybe do some work on it? Yes. And remember that for instance, if this is about the district in Ghana, I can pull out the northern region. And when I pull another region, because I'm doing districts in Ghana, all the districts of the northern region will be embedded in it automatically. Like for instance, the map we have just used to extract the northern region. If that map were to be the district map of Ghana, but we extract for another region, the northern region will come with all the districts within it, located as it is. So those who might want to do some regional district level work in northern region can focus on that one. So meaning that this polygon you're seeing over here will have had all the districts within northern region included in it. So if that is your interest, then you don't have to use the regional polygons of Ghana. You have to use what? The district polygons of what? Ghana. Then, even though you're interested in the district, you want to also get the region for the district to reside in the district, for the district to reside in the region. So you have to rather download the district map for Ghana, then extract according to the region. And when you extract according to the region, every district in that region will be included in the regional map for you. Okay, let's go. Here is one of the questions from one of the participants. I can't remember the name of head. He was asking me, so if you are interested in individual countries and you want to combine them for some work, meaning that, for example, if it's West Africa, you don't want to use all the countries in West Africa, just some of them, and you want to combine them. First, the same approach that I've used now can be used. First, extract the name of those countries out of the world map, or maybe the West African map, or the Sub-Saharan Africa map, or Africa map as a whole. Extract those countries you're interested in. Then, after extracting them, the next stage is to be able to map them. But during the extraction time, make sure you have a name that you can use for the combining. So here, I try to demonstrate using the same regional map of Ghana again. This very map. I try to demonstrate using the same regional map of Ghana, this one. And what is my demonstration all about? I want to separate northern region and then voter region from the map of Ghana. I want to separate northern region and voter region from the map of Ghana. And after separating them, My interest is to put them together, combine them, and use them for my work. Because there are only two regions I'm interested in. So what do? First, the same procedure. If I don't use a subset, the first one I use a subset. But if you don't use a subset, this is another procedure you can also use. This one, the same procedure you can use. The earlier one I use a subset function, but now I don't use a subset function. I want to use the column function. So here it will load the row. It will be calling the row and then the name of the variable the same. So if you watch, this part is telling you that I'm using the regional name as my main subsetting function. The regional name, which is name_1. And which region do I want to pull out? I say northern, as usual. Then that is in the row. The columns remain the same. When it comes to the voter also, this is how it is named in the shapefile, voter. So I give it voter and the same procedure. I pull a voter, column remain the same. Now, that is around this. So if you want to be sure, I can create another. So let me see, X11. Please, I'm almost done. So I know we are beyond time now. It's one, okay. It's 12 now. We are beyond, I'm almost done, don't worry. So this is northern. I'm creating a new one that I want to show. So with another one, oh, come on. Okay, I can just copy this one. So I'll call this one northern. So I plot this. So this is for the north, okay? That's another one. And then I do the same for voter. Just for you to see that we have actually extracted this correctly. So this is voter. This is voter for you, okay? So if you look at the map, this is where voter, it is voter. This voter. And we have just extracted this one, this voter. Now the next assignment for us is to combine both voter and what? Another region. And the function for you to do that is bind. The function for you to do that is bind. So I'm naming the two regions as poly. And the function to do that is bind. And I'm putting another region and then voter region what? Together. So I run this one. And remember, because these are all shapefiles, so when you even combine them, they are still going to be what? Shapefiles. These are all shapefiles. So even when you combine them, they are still going to be what? Shapefiles. So you run the class. So if you check, you realize that this special polygon or data from which is a shapefile actually. Now, see, if you combine them, we'll see what will happen. Plot. Now look at a map of Ghana and see their positions. Northern region is actually at the top of voter region. And that's what we are seeing here. Do you see? So you have now put them together. So any work you want to do, you can do it with them. You now have, so you can save this one now as your new polygons, special polygon data frame. You can save this one also as your new special polygons or data frame that you want to use. That's it. Okay, the session will end automatically in about a few minutes, but I'm almost done, so don't worry. Please, can you hear me now?
Yes, we can hear you.
Yeah, I'm almost done. So the last bit of it is this one that I want to do, then I run away. The rest you can do it. If somebody asked, how do you convert from degrees to meters the other time? So that's the next thing. So I'm still going to maintain our regional data for Ghana. I'm going to speed up because I'm told the system will automatically shut down when the time is over. So, but this is the next one I want to finish. And the other one is just a similar assignment that we did. So you're going to try. So plot this one as this equal to true. So you see, this one comes with the degrees. Is that not it? Then for you to transform, you need what you call the EPSG code for the country. For Ghana is 32630. So all you need to do is to give a SP transform, then bring the name of the data, then the coordinate reference system. That's what you need here is this one, EPSG. And then each country have their own code. So you have to look for the country that you belong or you want it for. For Ghana is this code. So if I run this one, it will not change this one from degrees to what? Meters for me. So this is the original one that you have here. So let me shut this up. I just want you to compare something. So quickly, X11, oh, come on. X11. So I create a new one. So this is the one that this will take. So the new one we created is this one. So you see now, we convert from degrees to what? Meters. Very nice, isn't it? From degrees straight to meters. So just this simple line, a single line, of course. Let me see. Am I sure a single? Yes, just a single line. This single line will transform your coordinate from degrees to what? Meters for you. And if you want to have it in kilometers, just divide each of these by 1,000. I think 1,000 meters make 1 kilometer. So if you want to have it in kilometers, just divide this by 1,000 or so. You can check, but I think that is it. So that is all. On that note, if you have some questions, I have a question here that you have to go and load, just as we did for the lattice data for Ghana. I have the same lattice data but for what? Tanzania. So please go and load it. The files are there for you. Go load and then try your luck. On that note, I'm done.
Sorry, can you show the data that we use for Tanzania?
Come again?
I want to see, I want to know which data we're using for Tanzania.
Yeah, it's the one we call TAN. Let me just go to the, where are you? Modeling, TAN. So you start from here, you end up here. So go to the procedure, just as we did for the COVID-19. But if you want to go straight there, use this one. TAN new is the one, the final one, this one.
Okay.
And
Can we go to the R markdown file? Because I'm not seeing the file that we use.
which file?
So say where we start was mapping child malnutrition in Tanzania. In that section, there's the file that we have to use, but I think
you mean the PDF? You mean the PDF?
Yeah, in the PDF, yeah.
Okay, let me see. Yeah. For Tanzania is there because I saved them in the, let me just go more PDF Joe.
There.
Mm-hmm. Which one do you say you're not seeing?
So there where you have assigned the data to 10.
To what?
The last, yeah, that last line there.
Is it not this one?
Not that one, the last one. So the read, what is that?
This one? This one?
Yeah, that one.
No, this one is, I'm using my directory straight. I'm using my directory. I didn't set a directory. I'm using it straightforward. It's the same thing.
Yeah, so at the end, what is the data called?
No.
The data set.
Okay, no, okay, then let me get to the end of that function. I'll see their name because this one is truncated, so you can see it. So I'll have to go to the end. This one, that should be here. So at the end, we have it SDR underscore this one. Is that what you're seeing?
Yeah.
It's there. This one is there.
Yeah, but it's not there in our file though.
Okay, no
So
problem. Let me just check. It's okay. No problem. Let me just check.
Okay.
That should be 15, right? That should be 15. This is, let me see. This is sub-national SH. Okay, these are save files. 15. SH. It should be this one. Is there?
Okay, I'll just
Is
tell
there?
you next.
Is there? You remember that the last one is the name of the this thing, the file itself, not the folder. The last one that we put all the time is the name of the folder. Let me see here.
It's 2015.
You see, the last part of it here is the name of the folder. So you have SDR underscore subnational underscore data underscore DHS underscore 2015. And that is just what you have there. So you have to copy this one and put it somewhere where, meaning that in your case, you have to get this one because I was using it directly. I was using, look at it. And like I keep saying, your directory, see, you have underscore, no, you have / SHPS. Is that not it?
Yeah,
And
I get
that is the last folder, which is this one. That's the last folder, which is this one. Then you
Yeah.
open this one, then you see what is in there. So it's there, it's there.
Yeah, I see it's there, but like I said, it's not on the R markdown file, so that was a little tricky.
Yeah, no,
but
yeah, because there's a truncation on the add markdown.
Yeah.
Yeah. But it's the same, but you have the same data as in CSV file already in this thing. Where is it? Let me just show you the TAN. Those are the data actually here at different levels. But please, so maybe I'll send you this one in the chat right now so that you can find a way of noting it for that one. That this is what you need. Yeah. But
That's good.
again,
Thank
please
you.
remember, my this will not work for you. My how will I put it? My working directory will not work for you. So always just try to adjust it to where you yourself you have assigned your working directory. So let me see.
Yeah.
To everyone in the meeting. Okay, I just drop it in the chat now. So please copy it and put it somewhere so that you know this is how I read it.
Okay.
Yeah.
Thank you.
No problem. Please, there's scripts for extracting and then merging two regions. It's already in the PDF, okay? All that I've done, they are there. So please just copy the codes there, they are there. So let's go back. This one, we extract Northern and then Volta here. We come back here, we combine them, and then we plot them here. And this is the result. So everything is on the PDF, please. Nothing is hidden. I mean, somebody's asking for the codes to do this too, but they are already there. They're in the PDF. So please get a PDF. And each of them have their heading, merging through combining polygons. So when you get there, everything you need is there. If no further questions, I want to thank you very much for all your time. And then for giving me a peace of mind to deliver my workshop successfully. On that note, thank you. And those of you who have sent me individual requests, I hope I've not disappointed you. I've been able to include all those things now in the updated version, which you can easily play with like we have demonstrated today. And thank for those who have reached out to me for some helps, which I have done. Thank you very much. Thank you. And then I wish you all in the remaining sessions. Thank you.